Recently, the James Webb Space Telescope has unearthed a mysterious ancient galaxy, and it might completely change our understanding of the nature of dark matter and the process of galaxy formation. The telescope has managed to spot a stellar population bigger than our home Milky Way galaxy from 11 billion years ago, and it shouldn't actually exist. This galaxy is massive and is home to extremely old stars. They formed in the early universe. The problem is that this new observation upends our current cosmological models, since, by the time of the galaxy's birth, not enough dark matter had built up to seed such a formation. Researchers have been chasing this particular galaxy for 7 years. They spent endless hours observing it with the help of the 2 largest telescopes on our planet to figure out how old it was. Unfortunately, it was too faint and too red, so no one could measure it. Only after scientists moved their observations to space and started using the James Webb Telescope did they manage to confirm the nature of the galaxy. The thing is, unlike the Hubble Space Telescope, which orbits around Earth, James Webb moves around the Sun 1 million miles away from Earth. That's why it made it possible to see the galaxy clearer. Previously, astronomers were sure that in early cosmic times, there were very few huge galaxies. But recent findings challenge these theoretical models. Extremely massive dormant galaxies have been discovered as early as 1 to 2 billion years after the Big Bang and the beginning of the universe. The scientist who led the spectral analysis of the James Webb Telescope data said that they were doing everything possible to confirm the oldest galaxies that existed deep in the universe. When they did, it pushed the boundaries of the current understanding of how galaxies form and evolve. And now, the main question is, how they managed to form so fast in the early universe, and what enigmatic mechanisms made them stop forming stars all of a sudden while the rest of the universe was still doing so. Galaxy formation is largely dictated by the concentration of dark matter. You see, around 84% of matter in the universe doesn't emit or absorb light. Astronomers call this stuff, which can neither be seen directly nor detected by indirect means, dark matter. It supposedly affects visible matter, radiation, and the very structure of the universe. Finding extremely massive galaxies so early in the universe is posing serious challenges to our standard model of cosmology. All because astronomers don't think that such monstrous dark matter structures as the ones hosting those massive galaxies had enough time to form. Researchers need more time to figure out how common such ancient galaxies are and how massive they can be. But if they manage to find more of those, it will really upset our ideas of galaxy formation. But it could improve our understanding of the physics of dark matter. Bizarre ancient galaxies aren't the only thing discovered thanks to James Webb. For example, scientists have long suspected that supermassive black holes could have existed in the early universe, and this theory has been proven only thanks to the JWST and its infrared eye. It showed that an ancient black hole within galaxy Sears 1019 was actively munching on all the matter it could lay its hands on. This hole is from the times when our universe was less than 600 million years old. And that's another mystery we're yet to crack. It's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. Astronomers were watching the galaxy hosting the unusually old black hole as part of the Cosmic Evolution Early Release Science Survey. They saw the galaxy as it was when our 13.8 billion-year-old universe was just 570 million years old. Besides the ancient black hole, scientists spotted 2 other ones. Those probably appeared 1 and 1.1 billion years after the Big Bang. They also discovered 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history.
The James Webb Space Telescope, an astounding piece of equipment built to outperform the Hubble Space Telescope, has made a terrifying and amazing discovery that might completely change our perception of the universe. It has successfully detected a faint glow coming from a staggering 7 trillion miles away. Can this glow be shining city lights coming from some mysterious extraterrestrial world galaxies away from us? Well, let's start from the beginning. A few years ago, NASA's Infrared Spitzer Space Telescope helped us spot a family of 7 rocky exoplanets orbiting the same star. This star is known as TRAPPIST-1. And recently, our new infrared powerhouse, the James Webb Telescope, has measured the temperature of one of those distant worlds. It was a planet called TRAPPIST-1b. Unfortunately, it turned out that this Earth-like planet was totally uninhabitable. Astronomers took James Webb's mid-infrared camera, called MIRI, and looked at the planet's thermal emissions. We can picture the whole process as scientists using heat-sensing Terminator vision. The results were quite disappointing. TRAPPIST-1b turned out to be scorching. Its average temperature was around 450 degrees F. That's as hot as in an oven. Plus, the planet most likely doesn't have any atmosphere. At the same time, this discovery was another record-breaking first for the telescope, which had already produced some newsworthy results by that time. It was the first time researchers detected any form of light emitted by a small and relatively cool exoplanet similar to the rocky planets in our own solar system. No previous telescope had enough sensitivity to measure such dim, mid-infrared light. When 7 TRAPPIST-1 exoplanets were first discovered, the astronomical community was ecstatic. That's because all those faraway worlds were about the size of our home planet and located in their star's habitable zone. It's the region that is just the right distance away from a star for liquid water to exist on a planet's surface. Thus, the planetary system became the best place to look for rocky planets with an atmosphere. But don't get too excited yet. These planets aren't likely to become new worlds for humans to explore, mostly because the TRAPPIST-1 planets are totally out of our reach at the moment. They're just too far away, at a whopping 235 trillion miles away. Their star is also much smaller and redder than our Sun. It's classified as an M-dwarf star. In our home Milky Way galaxy, there are twice as many of such stars as there are stars like the Sun, and they're also twice as likely to have rocky planets orbiting them. It's probably not surprising that astronomers are very interested in such stars. They're the main targets for seeking potentially habitable planets, and it's also way easier and more convenient to observe rocky planets around such smaller stars. But there's a catch. M-dwarfs are more active than our Sun. They frequently flare and spew high-energy rays which are likely to be extremely damaging to planets' atmospheres and any forms of extraterrestrial life. When researchers examined TRAPPIST-1b before, their observations weren't sensitive enough to determine whether this world had an atmosphere, or if it was just a barren rock. But now, we know. The planet is tidally locked to its star, which means that one of its sides always faces the star, while the other is stuck in perpetual darkness. The latest simulations suggest that if this planet had an atmosphere, its temperatures would be much lower since the air would redistribute the heat around both sides of the planet. Unfortunately, the James Webb Telescope recorded much hotter temperatures than needed for such a favorable scenario. It indicates the absence of an atmosphere and knocks the planet off our list of possibly habitable worlds. But the main excitement here isn't actually the features of TRAPPIST-1b. The main takeaway is that James Webb is capable of making such kinds of measurements. It'll help us explore the atmospheres and temperatures of many other distant worlds. The James Webb Telescope, or JWST, is like the ultimate intergalactic paparazzi. It takes pictures of some of the most famous celebrities in the universe. Stars, galaxies, exoplanets, you name it. The James Webb Space Telescope will snap a photo. So if you're a fan of cosmic celebrities, let's take a look at some of these best star-studded photos. The Carina Nebula. The image of the nebula with the beautiful name Carina was published on July 12th. JWST captured a beautiful view of the nebula, located about 7,500 light-years from Earth. Nicknamed the Cosmic Cliffs, it is, in fact, a hotbed of young stars, some of which are several times larger than our Sun. The Carina Nebula is a celestial spectacle located in the southern constellation Carina. It's really huge, approximately 260 light-years across. Massive stars within this nebula are so bright and hot that they create a glowing cloud of gas and dust around them. The Carina Nebula also contains swirling clouds of gas and dust where new stars are being born. The gas collapses under its own weight, becomes hotter and denser, and all this eventually leads to the creation of new stars. However, the Carina Nebula isn't just some peaceful place of star formation. It's the site of some of the most destructive events in the universe, which create massive shockwaves that obliterate everything in their path. Very chaotic and cool. The Stephan's Quintet. This photo was also posted on July 12th. Stephan's Quintet is a visual group of 5 galaxies located at a huge distance from us, about 290 million light-years in the constellation of Pegasus. It's like a cosmic family reunion. All these galaxies are related to each other and interact with each other in some interesting ways. They're pulling and tugging on each other with their gravity, constantly exchanging gas and dust. This interaction is causing some of the galaxies to collide and merge, which can create all sorts of cool effects, like bursts of star formation and supernovae. Thanks to JWST, we were able to see shockwaves, tidal tails, and other amazing details about these galaxies. Their interactions create a stunning sight that we can see in this photo. Jupiter. And here's our old giant friend. This image was published by NASA on August 22nd. Jupiter is the largest planet in our solar system, and it's known for its many moons and its beautiful swirling clouds. But it also has a system of rings, just like Saturn, which are made up of tiny particles of dust that orbit the planet. These rings are much smaller and less visible than Saturn's, but they're still pretty neat. Jupiter also has auroras, which are colorful light displays that occur in the planet's atmosphere. They're caused by charged particles from the solar wind interacting with Jupiter's magnetic field. Just like on Earth, they can be seen near the poles of the planet. But these auroras are much brighter and more intense than ours. We can even see this crazy light show from space. And now, we were finally able to capture this dazzling sight. JWST's photo shows the auroras of Jupiter, its rings, and even 2 moons, Amalthea and Adrastea. It's amazing how bright and clear they are on this photo. The Cartwheel Galaxy. NASA released this image on August 2nd. This photo shows us the Cartwheel Galaxy and its companions. The Cartwheel Galaxy gets its name from its shape. It kind of looks like a cartwheel, doesn't it? This is a giant swirling mass of stars, gas, and dust, which is located in the depths of space. It's shaped like a pinwheel with long spiral arms. These arms are held together by the gravity of the central region, which is home to a supermassive black hole. But the Cartwheel Galaxy is a bit different from its spiral relatives. It has formed when a smaller galaxy collided with a larger one, creating a shockwave that rippled through the gas and dust. We'll definitely have to visit this galaxy someday. It's sure to be a wild ride. Spiral Galaxy M74. And here comes another spiral galaxy. NASA released this image on July 22nd. JWST had to peer through thick layers of dust and gas to see this beautiful star cluster. M74 belongs to a special class of spiral galaxies known as the Grand Design Galaxy. This means that its spiral arms are noticeable and clearly outlined. All sorts of amazing things are happening inside of spiral galaxies. Supernovas, stars being born in clouds of gas and dust, and many other cosmic wonders. The glowing gas and dust, the bright stars, and the swirling patterns of the spiral arms make them some of the most striking objects in the universe. Well, we can clearly see it on the example of M74. The Tarantula Nebula. This image of the nebula with a creepy name Tarantula was published on September 6th. The photo covers as much as 340 light-years across. This is a huge distance. Thanks to this image, astronomers have discovered new young stars that were previously shrouded in dust. The Tarantula Nebula is located 160,000 light-years away from us, in the Large Magellanic Cloud. It's the largest and brightest star-forming region in the local group, the galaxies nearest our Milky Way. It's named after its shape, which looks like a bit like the legs of a big tarantula. It's a vast region of space, about 1,000 light-years across, and it's home to some of the most massive and luminous stars in the universe. One of the reasons why the Tarantula Nebula is interesting to scientists is its composition. Its composition is close to the region of stars of the cosmic noon, the so-called state of our universe when it was only a few billion years old. At that time, star formation was at its peak. Thanks to the Webb telescope, we can study this galaxy better and find out what our universe was like at its peak. Neptune's rings. This photo was published on September 21st, 2022. In this photo, we can even see 6 small moons next to the planet, with Triton shining brightly in the upper left corner. You didn't think it was the sun, did you? And yep, Neptune has rings too. They're like the ultimate cosmic accessory. They add a touch of glamour and style to the planet. But unlike some earthly bling, these rings are made of small particles of dust rather than diamonds and gold. There are 5 known rings around Neptune: the Gall, Leverrier, Lassell, Arago, and Adam's rings. Scientists think that these are relatively young, much younger than our solar system and much younger than, for example, Uranus's rings. They were probably created when one of Neptune's inner moons got too close to the planet and was torn apart by gravity. We haven't seen Neptune's rings so brightly since Voyager 2 flew past it back in 1989. So this is a great opportunity to take a closer look at these rings. The Pillars of Creation. This photo was published on October 19th. The Pillars of Creation became famous thanks to the Hubble telescope, but this photo is very lush and much more detailed. These columns, located in the Eagle Nebula, are about 5 light-years tall, which is really, really long. And they look like some majestic rock formations, only much more transparent. Just like a typical Hollywood movie set, they're full of action and special effects. They're home to some of the most dramatic processes in the universe. The gas and dust are collapsing under their own gravity, forming clumps that will eventually become stars. The place is full of intense radiation, jets of high-energy particles, and supernovae. It's like a cosmic version of Survivor. And if this wasn't creepy enough, here's another photo published by NASA on October 19th. They shared it right before Halloween. Here, the pillars resemble an eerie hand reaching for something. Brrr. Anyway, all these photos give us a truly awe-inspiring sight. They remind us of the incredible complexity of the universe and the amazing things that are happening even in the darkest and most remote corners of the cosmos. Let's hope that the James Webb Telescope will continue to amaze us in the future.
Wow, the James Webb Telescope has been fully deployed. If you're interested in astronomy or space, you've got to be excited about the James Webb Space Telescope. Here's why. For starters, it's huge. How huge? The primary mirror of the JWST is over 21 feet wide. The Hubble Space Telescope, the previous largest eye in space, has a mirror of about 7 feet 10.5 inches. By comparison, if you place the 2 telescopes side by side, it'd be like putting a horse next to an elephant. And elephants are enormous. There's a perfect reason why the Webb, as it's affectionately called, is massive. It has to be huge because it's not an optical telescope in the traditional sense that most telescopes are. The JWST is an infrared telescope. It sees heat. Infrared light has a longer wavelength than visible light, so it needs a larger mirror to focus that light. So what do we have here with the James Webb Space Telescope? We have 2 never-before things going on. We have incredible technology and incredible science missions. Both the missions and the technology are out of this world cutting edge. The Webb is a classic example of engineering in the service of science. Because of its greater light-gathering power, the James Webb Space Telescope will be able to take images of things that we were never able to see before, but have always wanted to see. Things like exoplanets, and the first galaxies in the universe, and stars and planets forming inside nebulae. And you can bet that there will be plenty of surprises too. The James Webb Space Telescope has several technological tricks up its sleeve, which promise to provide its greatest scientific discoveries. The Webb has a coronagraph, and a very special coronagraph at that. The coronagraph is the tool that will allow the first real pictures of exoplanets. The coronagraph blocks out the bright pinpoint light of stars, which we already know have planets orbiting around them. Without the coronagraph, the starlight would make things too bright to see these planets, because planets are hundreds of thousands of times dimmer than the star. But with the coronagraph blocking the starlight, the exoplanets come into view, and the JWST coronagraph can block the light from up to 100 stars at once. We can expect a swarm of exoplanets. This brings us to the next high-tech gadget the JWST has up its sleeve, a no-slit spectrograph. Usually, an ordinary spectrograph will have a slit to allow a sliver of light to enter and be diffracted. Diffraction is the scattering of light to reveal the spectrum of the light's component wavelengths. But the James Webb Space Telescope's work is so sensitive that a sliver of light would overwhelm the optics. So a no-slit spectrograph was installed. The starlight gathered from the big mirror is sent into a fiber optic cable to send only a single spot of light into the spectroscope. And that's where the grism takes over. Sir Isaac Newton used a prism to discover the spectrum of sunlight, Roy G. Biv, as you may recall. But the Webb uses a grism. That's a compound word, like smog, which is smoke and fog. A grism is a graded prism. That means it has itsy-bitsy, teeny-tiny grooves that diffract the spot of light the big mirror sends down the fiber optic cable and into the spectrograph. The science of reading a spectrum of light is called spectroscopy. By analyzing the spectra of light from the exoplanets, the JWST will determine what gases are in the planet's atmospheres, as well as their density and even their temperature. It's an incredible advance in our knowledge. We'll be able to tell if a planet has oxygen or nitrogen, or methane, and other gases that may or may not indicate that the planet is habitable. Another Earth, perhaps. Presently, the JWST is parked in its permanent location. Unlike the Hubble Space Telescope, which orbits the Earth, the James Webb Space Telescope orbits the Sun. It orbits the Sun at one of the gravitational balance points between the Earth-Sun system. It just stays there without having to use much or any fuel to hold its position. So, as the Earth orbits the Sun, the James Webb remains parked at a spot that is also orbiting the Sun. There are 5 gravitational balance points between the Earth and Sun. They are called Lagrange points, after their discoverer, Joseph Louis Lagrange, in the 18th century. The Webb is parked at L2, the second of the 5 Lagrange points, which lies 932,000 miles out into space, way beyond the Moon. All this to observe a spot of infrared light. But first, the engineers must get, or acquire, that spot of light. To get a spot of infrared light, the 18 hexagonal mirrors had to be unfolded from their position inside the Ariane rocket that sent the Webb into space. Once the mirrors have unfolded, their positions must be adjusted to microscopic level accuracy so that all 18 mirrors produce a single image. Several tiny motors are attached to each mirror segment to make these adjustments. These motors, which must be activated individually, will gradually pull the honeycomb-like mirror segments into alignment. It's a critical part of the mission and takes months to complete. To align the mirrors to produce a single spot of light, the James Webb Space Telescope can't be jiggling around. The telescope must be kept absolutely motionless, and that requires 2 other cutting-edge technologies, the sun shield and the cryocooler. In space, direct sunlight is very hot, and shadow is very cold. Therefore, the James Webb Space Telescope brought along its own high-tech sun shield. It's huge, too, as big as a tennis court huge, comprised of 5 individual layers of Kapton film, only a millimeter thick. Each layer of the sun shield has to be remotely deployed individually using a system of 8 motors and 139 actuators with thousands of parts. The purpose of the sun shield is to help the JWST stay cold. The colder the better. And colder is what the cryocooler is for. Temperature can be measured 3 different ways: in degrees Fahrenheit, where water freezes at 32 degrees and boils at 212; in degrees Celsius, where water freezes at 0 degrees and boils at 100 degrees. But neither of these thermometers have a starting point. So, Lord Kelvin, in the 19th century, devised a 3rd temperature scale, the Kelvin scale, which starts at absolute 0, the coldest temperature possible. The onboard cryocooler will cool the JWST to just 7 degrees Kelvin, 7 degrees above absolute 0. At this temperature, virtually all heat from motors is removed, and the telescope will be able to focus the light to a point without any noise, basically any motion interfering with the quality of the image. Finally, after all this incredible technology functions remotely as planned, we are almost ready to observe the infrared images from the giant multi-segmented mirror of the James Webb Space Telescope. Almost ready. A telescope can collect all the light it wants, but in the end, it must also be able to detect what it's collected. If the light is not detected, it's not truly observed. Enter the pièce de résistance, the infrared detectors. The Webb has 15 of them. The specially fabricated semiconductor material produces a slight electrical charge when struck by a photon of infrared light. The Webb's infrared detectors can produce a 1,000,000-pixel high-def image. A few of the detectors can produce a 4,000,000-pixel image. They must be durable enough to last 10 to 20 years without warping or corrupting, all while working at 7 degrees above absolute zero. In themselves, the infrared detectors on the JWST are an engineering marvel. But what are they going to take pictures of? The missions of the JWST. Well, they're cutting edge too. 70 of the first 280 target observations are exoplanets. Is there another Earth? Which exoplanets seem habitable? The Webb telescope will provide detailed spectroscopic analysis of the atmospheres of thousands of known exoplanets. For the first time, we will see images of exoplanets as they appear in infrared light. Cosmology, the study of the universe, is perhaps the primary mission for the Webb. Galaxies receding away so fast that their light is stretched into the infrared will be a prime target for observation. Hundreds of hours of observations are necessary to collect the faint infrared light from these first galaxies formed after the Big Bang. The JWST will give us a picture of what the infant universe looked like. Astronomers will learn new information about the dark energy that is driving the expansion of the universe and what role, if any, black holes play in the formation of galaxies. Star formation in the Milky Way and nearby galaxies is also part of the mission of the James Webb. By imaging hundreds of solar systems forming around newborn stars, astronomers will establish a definite history of solar system development. Now fact will replace theory, and a big step forward will be taken in our understanding of space. The James Webb Space Telescope is a bold endeavor that will mark an epoch time in scientific history.
It took a lot of time for the light emitted by several incredibly old galaxies to reach the James Webb Space Telescope. After scientists made more precise estimates, it turned out that the photons had been on the way for over 13 billion years. That's about as long as the entire history of the universe, and only recently have they reached our orbiting observatory. These dramatic results have revealed that the universe started creating stars almost immediately after the Big Bang. But if you look at the images delivered by the James Webb, you won't be overly impressed. Just a handful of smudges, a few glowing spheres, and something resembling a dog bone. And still, the world of astronomy has been left speechless. The telescope's giant mirror has managed to capture the oldest known galaxy in the entire universe. The galaxy got quite a prosaic name, mostly consisting of letters and numbers. Yeah, that's rather catchy. It appeared a mere 320 million years after the Big Bang. In comparison with our home galaxy, this ancient one was tiny, but after its birth, it started vigorously producing new stars at a rate comparable to that of the Milky Way. Interestingly, the Webb telescope has managed to photograph a few other ancient galaxies that had the same characteristics. Based on the snapshots of the baby universe we've got, we can conclude that in those ancient times, the first galaxies and stars were evolving amazingly fast. They also appeared much earlier than most scientists thought. Now, let's talk about the hero of the day, the outstanding telescope itself. The James Webb Space Telescope is a stunning piece of equipment. It's around 100 times more powerful than the Hubble Space Telescope, and the latter has observed places that are 13.4 billion light-years away. The James Webb Telescope is also on the pricey side, to put it mildly. Even though originally the cost of the telescope was estimated to be just $1 to $3.5 billion, the entire process of its construction cost around $10 billion. For comparison, NASA spent $4.7 billion to build and launch the Hubble telescope, and it was another $1.3 billion to fix it in orbit. Even though the James Webb Space Telescope itself is 3 stories high and the size of a tennis court, its mirrors are the lightest large telescope mirrors of all time. No wonder, during the manufacturing process, they underwent a 92% reduction in weight. The lighter, the cheaper it is to send stuff to space. If you had a chance to look at these mirrors, they would seem to be gold, but they're made of beryllium. This is a steel gray, lightweight, and brittle metal. A gold coating is still applied to each mirror, but they can't be produced entirely out of gold since this material needs to expand and contract even with small temperature changes. And that's not what we need to happen to a super precise piece of equipment. That's why the total amount of gold used in the construction of the James Webb Telescope is less than 2 ounces. That's a golf ball-sized chunk of gold. The gold plates covering the mirror are only 1,000 atoms thick. If we speak about all those incredible feats the telescope is capable of, it can clearly see a U.S. penny from 24 miles away and a football from 340 miles away. Hey, what's the score? JWST comes with significant advantages over any previous mission. For example, its 21-foot mirror is composed of 18 gold-plated hexagonal segments. They gather more than 6 times as much light as the Hubble Space Telescope's almost 8-foot mirror. It means that James Webb can record light from all kinds of space objects 6 times faster than its predecessor. The telescope's sensitivity to infrared light is also astonishing, which is remarkable since it can see different things than optical telescopes. You can say it's a real game changer. The James Webb can observe wavelengths from 0.6 to 28.5 micrometers, from the red end of the visible spectrum to the mid-infrared. As for Hubble's optics, most of the telescope's sensitivity is centered on visible light. It might sound surprising, but in its intended infrared domain, the Webb telescope isn't likely to resolve finer details than Hubble can detect in optical light. The thing is that although resolution increases with the mirror size, it also diminishes with wavelength. James Webb's telescope side cools itself down because otherwise it might get damaged or even burned. Normally, its temperature doesn't rise higher than minus 370 degrees Fahrenheit. That's cold enough to make hydrogen liquid. An enormous 5-layer sunshield surrounds the telescope and reflects as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. When the James Webb Space Telescope runs out of fuel, it'll just keep orbiting the Sun. On the other hand, even though the telescope wasn't designed to be serviced or upgraded, it might potentially be refueled with the help of robots in the future. This might extend its lifespan. Anyway, here are the reasons why we can say this telescope has changed astronomy. For one thing, we might finally see dark matter. Around 84% of matter in the universe doesn't emit or absorb light. Astronomers call this stuff, which can neither be seen directly nor detected by indirect means, dark matter. It affects visible matter, radiation, and the very structure of the universe. Dark matter is like some binding agent of our universe, and we're still not sure whether it exists. And now, thanks to the James Webb Telescope, scientists might finally have a way to seek dark matter. It's a huge development that is likely to change the way we observe the known as well as unknown universe. Even though astronomers haven't seen dark matter directly yet, they have been able to trace the distribution of this mysterious universal compound, all thanks to James Webb's powerful instruments. Another reason the new space telescope is so cool is that it helps us learn more about star formation. This process has always been a foundational part of astronomical studies. But even though Hubble has provided us with some iconic images and observations, there are still many unanswered questions about how stars form and go out. But astronomers are sure that James Webb will fill in the blanks. All because this telescope can peer further and deeper into the universe than any other telescope that has ever existed. Its location and cutting-edge equipment allow it to gaze through gases and dust surrounding early galaxies and stars. It will let us get a better look at star formation. It's also obvious that Webb's discoveries are bound to change the way we think of the early universe. For example, recently, the telescope has revealed several large galaxies that scientists believe existed not long after the Big Bang. They aren't supposed to be there, and no one expected to find them. And still, the James Webb Space Telescope has spotted them. These 6 galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age 5 to 700 million years after the Big Bang. The most bizarre thing about these galaxies is their tremendous size and the age of the stars inhabiting them. This information doesn't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. Plus, it doesn't match the earlier observations made by Hubble. Astronomers hope that one day, James Webb will help us find new exoplanets and even detect water there. For a long time, astronomers have been discovering planets orbiting stars outside the solar system by monitoring slight dips in stars' light. Such dips happen when planets pass in front of them, and reading unique signatures in the light can tell us about planets' chemical composition. The strongest and most readable signatures happen within the infrared spectrum. Have you just thought of James Webb's state-of-the-art infrared instruments too? They can help scientists spot new planets and even identify the presence of water there. The Hubble and James Webb Space Telescopes cooperate to explore space. Their observations complement each other and provide us with a broader view of the universe. But there are some significant differences between these two space explorers. Let's compare them. Currently, James Webb is the largest and most technically advanced telescope we've ever built. It can peer back over 13.5 billion years, observing the first stars and galaxies forming in the darkness of the early universe. The telescope's infrared vision cuts through massive clouds of gas and dust where planetary systems and stars form. This ability goes way beyond Hubble's infrared view, used for studying distant exoplanets. Hubble can actually observe space in near-infrared light, but it was optimized for shorter ultraviolet and visible wavelengths of light. This difference is what makes Webb and Hubble an awesome pair of observatories covering a broad wavelength range. Both Hubble and Webb are reflecting telescopes, which means that they use curved mirrors instead of lenses to gather and bend light to their numerous instruments. And still, these two have some obvious differences. Hubble observes the universe from an orbit just above Earth's atmosphere. That's why it needs to block stray light coming from the sun, as well as sunlight reflected by Earth and the Moon from entering the telescope. To accomplish it, the forward assembly of the observatory is wrapped in an insulated, aluminized Teflon light shield. This gives the telescope its tube shape. As for James Webb, it has a large, multi-layered sunshield that looks nothing like Hubble's light shield. And still, it serves the same purpose. Webb's primary mirror, which is more than 21 feet across, is way larger than Hubble's 7.9-foot one. No wonder Webb has more than 6 times the light collecting area that Hubble has. It's very important at the longer and dimmer wavelengths of light James Webb sees. You see, the universe is constantly expanding, and light from distant objects gets stretched when it travels to Earth. Shorter, bluer wavelengths of light stretch toward longer, redder wavelengths. That's why distant objects that look bright in blue or ultraviolet light turn red or redshifted once their light reaches Earth. They also get way dimmer. Webb's primary mirror gathers more of this dim, redshifted light, giving us clear views of objects 100 times fainter than what Hubble can see. Hubble is optimized to see ultraviolet and visible light. That's why its primary mirror doesn't need to be as cold as Webb's. More than 200 thermal sensors keep Hubble's instruments at optimal temperatures. An array of heaters warms the back of Hubble's primary mirror. That's where the observatory's science equipment is located. This part needs to be stiff and thermally stable. so Hubble's heaters maintain a temperature of 70 degrees F. As for Webb, it needs to be much colder than Hubble to capture those faint infrared wavelengths of light. The problem is, unlike visible light, we can't see infrared light with our eyes. But we can feel it because it's heat, or thermal radiation. When you turn your face toward the sun, you feel warmth. That's what thermal radiation is. To be able to capture the remains of the heat from objects so insanely far away, Webb needs to be extremely cold, minus 364 degrees F. To maintain this temperature, the telescope needs to shield itself from the infrared radiation coming from the Sun, Earth, and the Moon. That's why it has to be way farther from our planet than Hubble. Hubble orbits Earth 326 miles above the surface of the planet, but Webb orbits the Sun with Earth around 1 million miles away from home. From its perspective, the Sun, Earth, and the Moon are always in the same part of the sky. It allows the observatory's enormous sun shield to block the light coming from these space objects and keep the telescope cool. The gravitational forces of Earth and the Sun also make it convenient and easy for the telescope to hold its orbit. Webb only needs an occasional modest rocket thrust to keep its steady orbit. As for Hubble, due to its close proximity to Earth, it needs to deal with a dent in our planet's magnetic field. This dent is called the South Atlantic Anomaly, and it collects charged particles from the Sun. It tends to cause communication disruptions and problems with electrical systems. Hubble has to pass through this region 10 times every day, staying there for nearly 15% of its time.
The James Webb Space Telescope has recently discovered the oldest black hole ever found. It's an ancient monster as massive as 1.6 million suns, and it's lurking 13 billion years in the past at the center of an infant galaxy. This supermassive black hole appeared a mere 440 million years after the beginning of the universe. But it's just one of the countless black holes that inflated to terrifying scales during the dawn of the cosmos. It's the period about 100 million years after the Big Bang. That's when the young universe started to glow for 1 billion years. This discovery of the universe's oldest black hole can provide astronomers with the answers to some vital questions. For example, how could these space whirlpools balloon in scale so fast after the universe began? Or how did they appear in the first place? You see, black holes in the early universe couldn't grow as quietly and steadily as many modern black holes do. They were bound to experience some peculiar formation and growth. At the same time, closer to the present day, black holes are believed to be born from the collapse of ginormous stars. They grow by munching on gas, dust, stars, and other black holes non-stop. The friction created in the process makes the material, spiraling into a black hole, heat up, and it emits light that can be detected by our telescopes. To spot the oldest black hole, scientists used 2 infrared cameras, the JWST's mid-infrared instrument and near-infrared camera. They used the camera's built-in spectrographs to break down the light it had been recording into its component frequencies. While examining the results, they discovered unusual spikes among certain frequencies. It could only mean that the hot material around a massive black hole was beaming out faint traces of light. One of the most popular explanations for how ancient black holes grew so rapidly is that they appeared after sudden collapses of colossal gas clouds. Or they could form as a result of merges between clumps of stars and black holes. There's also a possibility that some of the oldest black holes could have been seeded by hypothetical primordial black holes. Those are believed to have appeared moments after the universe began, but their existence hasn't been proven yet. In any case, this most recent finding of the ancient black hole is extremely important because the formation of galaxies and the appearance of black holes go hand in hand. Every normal-sized galaxy that we know of has a black hole at its center. But even though such black holes are massive and can weigh millions and billions of solar masses, they are still tiny in comparison with their home galaxies. A supermassive black hole usually reaches less than 1% of the mass of a regular-sized galaxy and has a volume that is billions of times smaller. And still, somehow, supermassive black holes can influence galaxies, controlling the formation of stars for billions of years. The thing is, black holes exert an enormous gravitational pull on their surroundings. Any gas, dust, and stars that come too close to a black hole find themselves trapped. A lot of material crams into the space around the black hole and heats up, because that's what materials do when compressed. Soon, everything around the black hole flattens into a thin disk, which is called the accretion disk, and starts swirling around the black hole. Astronomers believe that this process is behind the mysterious relationship between black holes and their host galaxies. It's a connection between the mass of the supermassive black hole and the velocity dispersion of the gas in the galactic core. This cycle also controls the rate of star formation, which is a crucial element of the evolution of galaxies. If this delicately balanced process goes off kilter, the outflows from black holes can get too strong, not only heating the gas in a galaxy, but also removing it altogether. And then, the formation of stars doesn't simply slow down, it stops completely. Major galactic merger events can lead to such dramatic consequences because too much material falls into the central black hole too fast.
So you're a giant titan who creates our universe from the ingredients in your locker. And so, you've got a beautiful sunburst arc galaxy. Let's put it about 11 billion light years away from the Earth. Now let's add brightness. Size? Oh, you accidentally hit the copy button. Oh no! Now there are 12 copies of this galaxy. Well, this scenario actually doesn't seem so impossible if you look at recent Hubble telescope images. There are 4 unusual arcs here. Number 1, 2, 3, and 4. And there are bright dots on each of the arcs. Each dot is an exact copy of the sunburst arc galaxy. So, we have 2 possibilities. Either someone created 12 perfectly identical galaxies, or it's just an optical illusion. Scientists are sticking with the second option. For starters, let's look at a lantern light at night. See that circle around the light? It's called a halo. It appears when there are lots of ice crystals or water droplets in the air. These crystals refract the light from the light bulb, just like a lens. And we, as an observer, see a bright circle of light. Well, that halo circle and the sunburst arc photo do seem a little similar, don't they? Well, it really does. But what in the cold and dark of space can act as a lens and distort light? We know that a heavy enough object can warp space and time. Let's take a giant net and say this is a space-time sheet. Now let's put something heavy, weighing as much as our sun. Notice how it sagged the net? And now there's a deep funnel here. And any object lying next to it will always fall into this funnel. That's how our solar system works. Small objects like planets and asteroids circle around the funnel with the sun. Now, put something supermassive in the center of the net, a black hole. It has sagged the net so much that we can't even see the bottom of the funnel. Now, no object, not even light itself, can escape from this gravitational trap. And if we look at known black holes, we can see this in action. They suck in the light like spaghetti, leaving remnants of it on the event horizon, but it'll soon disappear too. So the black hole bends the light, but doesn't let it get to Earth because it's too heavy. But if you put something lighter on the space-time net, it can barely warp it. We need something in the middle, something that will warp light but not absorb it, a cluster of galaxies. Let's trace the process from the beginning. So here's the sunburst arc galaxy. It's releasing photons of light. These beams are traveling toward Earth at incredible speeds. At that speed, you could travel 93 million miles from your home to the sun in just 8 minutes. These beams then encounter a cluster of galaxies about 4.6 billion light years from Earth. This cluster acts like a lens, only it uses gravity instead of curved glass. The rays split and circle the cluster of galaxies from different directions and continue their movement toward Earth. As a result, to observers, it looks like arcs of light, each with a light copy of the galaxy. But which of these 12 copies is the real galaxy? Well, none of them. But at the same time, all these copies are one real galaxy. That's how optical illusions work. And here's the cosmic horseshoe. This bright blue arc is a system of 2 galaxies in the constellation Leo. The same thing is happening here. The light from these 2 galaxies passes through a lens of another galaxy, about 100 times heavier than our Milky Way. So the gravitational lens is not only beautiful, but also incredibly useful for our scientists. There are a lot of faint and dull objects in distant space, and we can't see them at great distances. But gravitational lenses help their light to reach the observer, and then we can begin to study these distant cosmic objects. For example, the Sunburst Arc is an extremely old galaxy from a time when all space was dark and had no stars at all. It was the age of reionization, about 550 to 800 million years after the Big Bang. This is when the first stars began to appear. Their light helped to charge the universe, and after a few billion years, it took on the form that we see now. So, by studying galaxies like the Sunburst Arc, we can understand how our universe was born and formed. And such arc circles are only one type of lensing. The other type is the Einstein cross. Let's look into the constellation Pegasus. About 8 billion light years in that direction is a bright quasar. This is the active core of a galaxy, with a supermassive black hole at its center. It absorbs the stardust and matter around it and gets bigger and brighter. One quasar emits 100 times more energy than all the stars in our galaxy together. It's also the brightest object in the entire universe. Their brightness is estimated at plus 12.6 units. At the same time, the brightest observed star has negative 1.46. And we can observe how the bright light of the quasar bends and forms an Einstein cross. A beam of light flies to a galaxy 400 million light years from Earth and begins to warp. We as observers see the result: 4 bright points and the galaxy lens itself in the center. Perhaps in the future, the quasar will become a large galaxy and we'll be able to observe the process of its birth through this lens. And we know of about 100 such lenses in space. These are different galaxies far enough away from Earth and heavy enough to bend light. Given that there are about 2 trillion galaxies in our universe, only 100 lenses seems like very few. All because the galaxy or cluster of stars that refract light must be dim. If they're bright, we'll only see their own light. And even our Milky Way galaxy can be used as a lens. If there's some intelligent life far out in space, and they're exploring the universe just as we are, then they could point their telescopes toward our galaxy and see the curved light from the distant worlds behind us. Interestingly, even a small object like the sun can also bend light from other stars, but it bends the light at a very small angle, so you barely see this difference. And sometimes you can see the same copying as with the Sunburst Arc galaxy right here on Earth. And you don't even need a telescope. You can see 3 suns on the horizon in freezing weather. It's the same ice crystals that create the halo around a street lamp. They refract the light from the sun so that the circular halo has 2 bright dots on either side of the real sun. These dots are so bright and big that they can really be confused with a real star. A similar effect occurs with moonlight. The moon reflects the sun's rays to Earth, but the crystals in the clouds refract the light so that you see 2 blue dots next to the moon itself. But when it comes to gravitational lenses in space, they bend not only the light, but also the flow of time. The rules are simple. The bigger and heavier the object, the slower time flows near it. So if you find a supermassive black hole and can get to its heart, time can practically stop for you. 1 minute near a black hole can be equal to weeks or even months on Earth. But the Earth is also quite heavy, and it also slows down time flow. You can fly away from Earth far enough to get rid of its gravitational influence. Now you move through time a little faster than everyone else on Earth. And there's one person on Earth who has actually made such a journey. It's an astronaut who has been on the International Space Station for 803 days, 9 hours, and 39 minutes, and even 41 hours in outer space. And now he's moving through time ahead of all the inhabitants of Earth by 0.02 seconds. Let's go back to our space-time net. Let's put the Earth here. It's warped the net just a little bit, but it's enough to make the time flow at the center of the funnel differ from the time flow a few inches away. That's how this astronaut was able to time travel forward.
The Big Bang Theory doesn't explain how exactly our cosmos started. It's more like a story about what happened after, in the earliest stages of the universe. That's when all stars, galaxies, and specks of dust were crammed into a dot, no bigger than a peach with a temperature of more than 1 trillion degrees. Our cosmos doesn't have an edge or outside. The Big Bang wasn't an explosion that happened at some particular point. It was the moment when space itself began to expand everywhere at the same time. That's a process we call inflation. When the cosmos was nearly 1 million times smaller than today, everything was just a plasma that later expanded, cooled, and then converted into a neutral gas. That was the time when the first atoms formed. All these processes released enormous amounts of radiation. The cosmic microwave background, CMB, is the fossil of that radiation that dates back to about 380,000 years after the Big Bang. Before that, the heat from the creation of the universe was way too intense for even light to shine. Only after matter cooled down did it get lighter because the universe became less dense and more transparent. In the first 3 minutes of this process, certain light elements formed, such as hydrogen and helium. About 400 million years after the Big Bang, the cosmos slowly started coming out of its dark ages. This period probably lasted over 500 million years. Clumps of gas came together and formed something beautiful, the very first stars and galaxies. All this gave off lots of ultraviolet light. It was as if someone finally turned on a cosmic flashlight that cleared away the foggy gas that was all around. About 9 billion years later, our solar system got into the game too. It was born from this dense cloud of interstellar dust and gas. The cloud fell apart, possibly because of the shockwave produced by a star that exploded somewhere nearby in a spectacular supernova. This left us with a solar nebula, a disk of material that kept spinning. At its center, gravitational forces kept pulling more and more material in. At one moment, the pressure at the core became so great that hydrogen atoms started to mix and form helium. Like it happens with other processes in space, this released giant amounts of energy. And ta-da, we got our star. So big that it makes up over 90% of all the matter in our solar system. The remaining matter from the disk had its own job to do. It probably started off as grains of dust even smaller than the width of your hair. Gravity and other forces made clumps smash into one another. They got bigger and bigger. Particles of dust eventually evolved into pebbles, and then, as this donut-shaped disk of gas kept spinning, they turned into rocks. Meanwhile, the star pulled in nearby gas and pushed the rest of the material farther away. Those parts of the disk were far away from the sun, so water in those regions started to freeze. Soon, there were tiny pieces of ice flying around, gathering into dirty snowballs that became planetary cores. Since it was cold, gas molecules could slow down enough for a planet to draw them closer. That's how we got our famous gas giants, Neptune, Uranus, Saturn, and Jupiter. Jupiter and Saturn probably formed first, maybe even within the first 10 million years of the existence of our solar system. Parts of the disk that were closer to the sun remained warm. The material there gathered into rocky planets. After the icy giants appeared, not much gas was left for the other ones though. So, Mercury, Venus, Earth, and Mars ended up a bit smaller. They may have taken tens of millions of years to form after the sun was born. This is, of course, a very simplified version of how we got 8 planets in our solar system. Who knows if we'll ever know the whole truth? Time went on. Space debris was swirling around. Some objects became large enough for their gravitational force to shape them into spheres. That's how we got dwarf planets and big moons. Our asteroid belt is the region that separates inner planets from outer ones. It's full of pieces and bits from the early solar system that never grew into something bigger. They just kept on floating around, maybe waiting for another chance. Other smaller leftovers turned into comets, meteoroids, asteroids, and small irregular moons. 4.5 billion years ago, something else arose from all that chaos. A planet almost as big as Mars collided with Earth. And the debris formed the only moon we have today. Somewhere around that time, the Sun also got to a new level. At its younger stages, it was just a ball of helium and hydrogen that still wasn't powered by fusion. Over millions of years, it got hotter and more pressurized, and finally turned into the shining star we know today. It's supposed to stay like this for a very, very long time. Around 10 billion years. Simulations scientists have made to understand the creation of the universe show that the chaos of that time was even bigger than we thought. Orbits of the giant planets probably shifted during that period too. The gravitational force from many objects in the Kuiper Belt shook Saturn and Jupiter into a 2-1 resonance. That means Jupiter made a circle around the Sun twice for every Saturn orbit. This brought the two giants closer together, which wasn't good for their surroundings. There's a theory that Uranus didn't form where it is today, which is 20 times farther from our Sun than Earth. At this distance, there wasn't enough material to make the whole planet. That's why there's an idea that Uranus was born closer to the Sun before it got ejected farther away for some reason. Maybe that reason was the mess Jupiter and Saturn made. Some believe Neptune shares a similar destiny, together with the whole Kuiper Belt. As Uranus and Neptune were passing through the Kuiper Belt, they scattered most of the objects there. Any additional ice planets that had formed there also ended up kicked out, but in this case, entirely out of our solar system. Pieces of these scattered worlds that were located more outwardly stayed in the Kuiper Belt and the Oort cloud, a faraway sphere of ice bodies where the majority of comets come from. In all this chaos, the inner planets got hit. Scientists think that's how we got organics and water here on Earth. That's exactly what we needed for life to start developing, somewhere 3.8 to 3.5 billion years ago. We found evidence of microbes in the hard structures they made. Those are called stromatolites. They help us understand the earliest forms of life on Earth. Up until 3 billion years ago, Mars might have also been a good place for life. The red planet used to have a thick atmosphere and a strong magnetic field, just like Earth. But unlike our planet, Mars cooled from the inside, which switched off this whole mechanism. Without its magnetic field, nothing could protect the planet from the solar wind that pulled away most of its atmosphere in just a few 100 million years. Mars used to have magnificent lakes, rivers, and water streams that left traces we can see on its surface, even today. Luckily, Earth managed to keep its water, so life continued to evolve. 2.5 billion years ago, Earth got photosynthetic organisms that started pumping oxygen into the atmosphere and helped create the entire animal and plant kingdom across the planet. Another big thing happened in our solar system later. Saturn got its astonishing rings. No one knows for sure what happened back then, but a new theory says the rings aren't as old as the planet itself, only about 100 million years old. At the same time, something hit our moon and left Tycho crater, one of the most prominent craters on the lunar surface. Other planets couldn't avoid collisions either, including Earth. You already know what happened 66 million years ago. A giant asteroid triggered changes in climate and erased 3/4 of life, including dinosaurs.
The only life that we are certain about so far in the entire universe is on planet Earth. Whether that life is intelligent is, let's say, arguable. But anyway, it's not surprising that we're tirelessly searching for life on other planets. So far, they've discovered more than 4,000 of them. But what's even cooler, NASA has compiled a new list of 24 planets that aren't just Earth-like, they're better. The conditions on them are so good that they're more comfortable than on our planet. So let's examine some of them. Let's be koi, K-O-I, shall we? This wonderful planet is in the constellation Cygnus, and why is it so wonderful? Well, our sun is a yellow dwarf. And sorry, sun, even though you're not bad at supporting life, there are some stars that can do it better. Nothing personal. The planet KOI 5715.01 orbits near an orange dwarf. Orange dwarfs are stars slightly smaller than our sun and have a little lower luminosity. Did you like the alliteration there? Anyway, don't worry, it doesn't mean we're going to live in complete darkness. In fact, if the planet is found closer to the sun and it has a thicker atmosphere, it may even be lighter and more colorful than on Earth. Our sun has a very short lifespan. Right now, it has 7 to 8 billion years left to live, a little longer than the Earth's age. But orange dwarfs can live from 45 to 70 billion years. This is great not only because we'll be able to hang out on this planet longer, but also because the planets around these stars have more time to form life. Ideally, we need to find a planet next to an orange dwarf that is about 7 billion years old. It's very likely that there will be at least some organisms there. KOI 57115.01 is about 5.5 billion years old. Yeah, it may not seem mature enough, but that's okay, neither do I. Our Earth is a billion years younger, and that didn't stop us. The planet is quite close to its star and is in a habitable zone. 1 year there lasts 190 days. Imagine going to elementary school and already getting a driver's license. It's almost 2 times larger than the Earth. The average temperature there is 52 degrees, which is slightly less than ours, 57 degrees. But it most likely feels warmer there, because strong gravity helps it hold onto heat in the atmosphere longer. It's a little too far away though, like 3,000 light years from Earth, which is about 18 quadrillion miles. Yup, better bring a really big lunch with you. KOI 3010.01. This planet is found next to the star KOI 2010. This planet sounds like a very pleasant world. The average temperature on this planet is 67 degrees, so a little warmer than ours. But that's a good thing. Scientists believe that on a perfect planet, the temperature should be just about 10 degrees hotter than on the Earth. The more heat there is on the planet, the more comfortable it's to live there. Also, the higher chances of developing life. The radius of this planet is nearly 1 1/2 times larger than Earth. There's some atmosphere, although we're not yet sure about its composition, but it's probably like the Earth's. Scientists think that we'll find an ocean there, and it can cover up to 60% of the surface, which is also cool. In a perfect world, water and land should be distributed more evenly than on our planet. A little more land means a little more territory and resources, right? But listen, this planet is actually very similar to the Earth. The resemblance is so striking that scientists believe that we have an 84% chance to find life there. Of course, not necessarily an intelligent life, but at least some animals. Wouldn't that be cool? What do you think they could look like? Very Earth-like planet, but with stronger gravity. If someone lives there, they're probably big but have a small height and strong little legs. Sounds adorable and scary. But we won't be able to find out the truth anytime soon. So far, for us, these planets are microscopic dots in space. We only have some dry, boring data about them, and don't even know what they look like. We'll have to wait until we can find a way to get closer to these planets. Kepler 186f. This is also one of the best candidates for having life. This rather cute planet was nicknamed the Earth's cousin, because it does have a strong resemblance. Anyway, these two planets are like sisters, not twins. Kepler 186f rotates near the red dwarf. Red dwarfs are stars even dimmer and smaller than orange dwarfs. Yeah, they'll also live for a very, very long time, but their luminosity is also quite low. However, Kepler 186f is closer to its star than we're to our sun, so it shouldn't be too dark there. Well, at least not night-like dark. The sky on this planet is sure to be an unusual shade of red, like sunsets on Earth. What do you think? Would you like to live on a planet with an eternal sunset? The size of this planet is about the same as Earth. Not bad, not perfect. Why so? Because the coolest planets are those that are bigger than Earth and have stronger gravity. You'll probably say, but won't it be harder to walk there and even harder to get out of bed on Monday? Of course. But on the other hand, this planet will pull the atmosphere better. The atmosphere will be thicker and denser. This means more protection from the scary space stuff, more oxygen, and more heat. Not to mention the fact that the bigger planets have more space to settle. Awesome, right? But, of course, the Earth's size is also an excellent choice. Another cool fact is that the tilt of Kepler 186f is about the same as ours. It means that there should be stable seasons and a normal day-night cycle. Do you know how important the tilt of the planet is? Let's look at Mars. Mars is also, in fact, found in the habitable zone of our Sun, but its tilt is very unstable, and as a result, the entire ocean that could have been on it once now completely dried up. Today it's just a red desert, and there is no life there, at least not as far as we know. But you see how important these tiny details are? This planet is also quite far away from us, 490 light years. It's about 3 quadrillion miles. So yeah, we're just going to keep waiting for intergalactic travel. Kepler 62 Zens and Kepler 62f. These planets were called the most Earth-like before we discovered Kepler 186f. They're very comparable to our home. Kepler 62m is about 1.5 times larger than Earth, and Kepler 62f is just slightly smaller than that. They're located in the constellation Lyra, about 1,200 light years away from us. They both also orbit a red dwarf. 1 year on Kepler 62e lasts about 122 days, even less than on that first planet we've talked about. Scientists believe that both 62e and 62f are sort of water worlds. Warm places mostly, or even completely, covered with water. If there is land there, it's probably just some islands. A world consisting entirely of islands. A fantasy dream for some. Think Hawaii, and a nightmare for others. Think Megalodon. But if you're a fan of ancient marine animals, just imagine how gigantic they could be there. Still, there are many things we don't know about this planet. Does it have a surface? What is its composition? Density? One day, maybe we'll be able to answer these questions. And so, that's it for the super Earths. Of course, the original list is much longer, and you can go check it out on the internet. The best thing about all this is that these are the planets that are better than the Earth. But we also know thousands of other exoplanets that are just close enough to ours. And the odds are a few of them have at least some form of life. But they're very, very far away, so we have no way to check it right now. Perhaps down the road, we'll find some cool creatures on many of them. It's been more than a year since the James Webb Telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke. And it's quite a big deal since it has pushed the record for detecting similar, complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb Telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own sun. At the beginning of 2023, the observatory spotted its first exoplanet, CHES 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place. And Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR 124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VS 1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them, but the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age. 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see 3 massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens, and thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb Telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb Telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems, light years away from our own. Here is one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 378 trillion kilometers away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation. But this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress. When you look at photos taken from spaceships or the International Space Station that show sunlit objects like Earth or the Moon, something seems wrong. Space looks too empty. No magical scenery of a nighttime sky full of stars. It would be incredibly boring to go stargazing in space since the sky is always so dark. During the daytime, the sky on our home planet is blue because of the diffusion of light. It happens when sunlight goes through the atmosphere. But if you were on the moon or somewhere else in space, there would be no atmosphere to spread this light around. That's why the sky there would always appear black. But it doesn't mean it's less bright out there. If you were looking out of the window of the space station, you'd see just as much direct sunlight as you would gazing out of your apartment window during a cloudless day, maybe even more. When taking a picture on a sunny day, you'll probably use a short exposure, together with the narrow aperture setting on your camera. This way, just a short burst of light will get in. That's similar to how our pupils contract in sunlight so that they don't have to deal with too much light. And since it's just as bright up there in space, the process is the same when you take pictures of sunlit objects there. Using short exposure, you can get good, bright pictures of Earth or the surface of the moon, but it also means there will be no stars in the picture. Even up there, stars are relatively dim. They don't emit enough light to show up in photos taken with such settings. Our home planet has a blue sky that slowly transforms into a beautiful orange-red palette at dusk and dawn. But if you ever get a chance to watch a sunset on Mars, you should expect the opposite. An orange-brown daytime sky that gets a bluish tint at sunset. First of all, Mars is farther away from the sun than our planet. So when you're looking at the sun from the Martian surface, of course, it looks fainter and smaller. And not just that, the sun observed from Mars is just a bluish-white dot surrounded by a blue halo. The thin atmosphere of the red planet contains large dust particles. They create an effect called me scattering. It occurs when the diameter of particles in the atmosphere is almost the same as the wavelength of the scattered light. This effect filters out the red light from the sun's rays, so only the blue light would reach your eyes on Mars. How come Earth doesn't have rings? All gas giants in our solar system, Jupiter, Saturn, Uranus, and Neptune, have such rings, whereas the rocky planets, Mercury, Venus, Earth, and Mars, don't. There are two theories about how rings can appear around a planet. They might be just some material left from the times when the planet was forming, or they may be the remains of a moon that got destroyed by a collision with some space body or torn apart by the strong gravitational pull of its parent planet. The gas giants formed in the outer regions of our solar system, while all the rocky planets are in the inner part. So maybe the inner planets were more protected from potential collisions that could have formed their rings? There are also more moons in the outer regions of our solar system, which could be another reason why the planets there have rings. Also, bigger planets have stronger gravity. It means they can keep their rings stable after they form. Some experts believe Earth used to have a ring system a long time ago. A Mars-sized object might have collided with our home planet, which probably created a dense ring of debris around it. Some scientists think that this debris formed not a ring, but what we today know as the moon. There's probably a giant planet lurking at the edge of the solar system, far beyond Neptune. Scientists called this mysterious hypothetical world Planet 9. If it does exist, it's probably similar to Uranus or Neptune, and 10 times more massive than our home planet. It's likely to circle around the sun, but in the outer reaches of the solar system, about 20 times farther than Neptune. Another interesting theory says that Planet 9 could actually be a black hole the size of a grapefruit that warps space in a similar way a large planet would. Even though we once thought it was a rare substance in space, water exists all over our solar system. For example, you can often find it in asteroids and comets. It's also in craters on the Moon and Mercury. We still don't know if there's enough water to support potential human colonies if we decide to move there, but some amount of water is definitely present there. Mars has water at its poles too. It's mostly hidden in the layers of ice and probably under the planet's dusty surface. Europa, Jupiter's moon, has some water too. This is the most likely candidate we know about to host life outside Earth. There's probably a whole ocean of liquid water under its frozen surface. It might actually contain twice as much water as all of Earth's oceans combined. Neptune is unexpectedly warm, even though it's 30 times as far from the sun as our planet and receives less sunlight and heat, but it still radiates way more heat than it gets. It also has way more activity in its atmosphere than you'd suspect, especially if you compare it to its neighbor, Uranus. Both of these planets emit the same amount of heat, even though Uranus is much closer to the sun. No one knows why. Neptune has extremely strong winds that can reach a speed of up to 1,500 km/h. Can they produce this heat? Or maybe it's because of the planet's core or its gravitational force. There's a monster black hole hurtling through space at a speed of 5 million Mach. Scientists located it with the Hubble Space Telescope. They believe it weighs as much as 1 billion suns. It was supposed to stay put in the center of its home galaxy, but some gravitational forces are pushing it around. At one point, this black hole is going to break free from its galaxy and continue roaming the universe. Luckily, it's still 8 billion years away from us. Solar storms are so powerful they could leave us in complete darkness. Back in July 2012, the strongest solar storm in over 150 years narrowly missed Earth. Coronal mass ejections, or CMEs, are large bubbles of ionized gas. They tore through our orbit back then. If they had caught our planet in the crosshairs, we would have literally been in the firing line. We'd have faced solar matter hurtling toward Earth, damaging computers and causing power outages that would have lasted for months. A surprise solar storm hit us on June 25th, 2022. One photographer even managed to capture stunning bright auroras that flashed across the dawn sky in Calgary, Canada, and lasted for 5 minutes. Vampire stars are a real thing. They're part of a binary star, and they can literally drain the life out of the other star in the system. They do it to keep burning for a longer time. It works like this. A smaller star with a lower mass steals its sibling's hydrogen fuel to increase its own mass. This vampire star then becomes hotter. Plus, its color changes to striking blue. This way, it looks much younger. How sneaky. The color of the universe is dubbed cosmic latte. The light coming from galaxies and stars within them, as well as clouds of gas and dust in the observable universe, have a specific color. It's an ivory tint pretty close to white. The universe is beige because there are a bit more areas that produce green, yellow, and red light than those that emit blue. Jupiter is the largest planet in the solar system. More than 1,300 Earths could fit inside this gas giant. It's also 2.5 times more massive than all the other planets of the solar system combined. But if you think this is mind-boggling, I've got some great news for you. Very recently, a team of astronomers has discovered a much bigger planet with the help of the Subaru telescope and the NASA Hubble Space Telescope. It's a Jupiter-like protoplanet orbiting a very young star called AB Aurigae. The star is probably still forming and is no more than 5 million years old. For comparison, our Sun is 4.6 billion years old. The young star is located around 531 light-years away from Earth in the constellation of Auriga. The star is shrouded in a thick, quickly moving layer of gas and dust. This disk feeds the growth of the star. Later, what is left of this disk will come together to form the elements of the planetary system. Planets, dwarf planets, comets, asteroids, you name it. But back to the newly discovered planet. It's a gas giant whose mass equals that of 9 Jupiters. Can you imagine this colossus? It takes the planet, named AB Aurigae B, almost 588 Earth years to complete just one journey around its parent star. Maybe because it's 93.9 AU, astronomical units, away from it. Now, why is the discovery of this planet so amazing? Because according to astronomers, it's been forming in a very bizarre way. Or should I say, IS forming, since this gas giant is still in the process. Anyway, the unusual thing is that AB Aurigae B is coming together as a result of a top-down gravitational collapse of giant clouds of gas. But scientists say that a much more common model of planetary formation is when dust and rocks gradually accumulate around some kind of core. This proves the idea that there are numerous ways for planets to form. It can also mean that there probably are very diverse planetary systems in our home Milky Way galaxy. But AB Aurigae B isn't the largest exoplanet ever discovered. In 2005, astronomers spotted a mysterious space body. Later, they called it GQ Loopy b. The thing was orbiting a young star at a distance 2.5 times greater than that between the Sun and Pluto. Scientists came to the conclusion that the object was either a planet or a brown dwarf, which is basically a tiny star. If astronomers decide that GQ Loopy b is a planet, it will be the largest ever found, with a radius that is 3.5 times that of Jupiter. The biggest star we know about is called UY Scuti. This hypergiant has a radius that is about 1,700 times greater than that of the Sun. If you somehow managed to place UY Scuti in the center of the solar system, its edges would stretch far beyond Jupiter's orbit. As for the dust and gas streaming from the star, all this would extend beyond the orbit of Pluto. That's 400 times the Sun-Earth distance. A black hole is a spot in space where the pull of gravity is so strong that even light can't escape it. But why is gravity so powerful there? Because matter is squeezed into a teeny tiny space. Supermassive black holes, which can be many millions of times the mass of the Sun, tend to lurk in the centers of galaxies. The most massive black hole astronomers have discovered so far is TON 618. Its mass is equal to that of 66 billion suns. It was the year 2010 when, with the help of the Fermi telescope, astronomers spotted ginormous something entering the Milky Way. Their discovery looked like massive blobs of matter that could only be observed in particular wavelengths of light. They were also about 25,000 light-years tall. Scientists think that the blobs, called Fermi bubbles, could be produced by our galaxy's central black hole. Space seems to be extremely deserted, but some places are even emptier than the rest, like Supervoid and Eridanus. Astronomers noticed this huge region of empty space in 2004. The area stretches 1.8 billion light-years across. It's mysteriously devoid of gas, dust, stars, and even dark matter. A nebula is a massive cloud of gas and dust floating in space. Some nebulae form when a star is nearing the end of its life and throws out loads of gas and dust. Others appear in regions where new stars are forming. The largest nebula we know about is the Tarantula Nebula. In its longest span, it measures over 1,800 light-years. This nebula, also known as 30 Doradus, is located around 170,000 light-years away from Earth. Unlike its namesake, the tarantula isn't dangerous. Quite the opposite. It's a stellar nursery, which means it's a region where tons of young stars are born. Even cooler, it's the most active star-forming area in our entire galactic neighborhood. In 2021, the biggest ever comet we know about entered our solar system. It was 85 miles across, and its icy nucleus was 50 times greater than the nucleus of the previous record breaker. The intruder's mass was a whopping 100,000 times bigger than that of an average comet. In fact, C-2014 UN-271 Bernardinelli Bernstein was so large that astronomers first classified it as a minor planet. Is it going to crash into Earth? Nah, it won't get closer than 1 billion miles to our beautiful green planet, and it won't happen until 2031. But could there be comets even bigger than that? Who knows? But the thought is terrifying. There are loads of bizarre things in the universe, and hypothetical nuclear pasta is one of them. If it does exist, nuclear pasta is the strongest material in the entire universe. It forms from the leftovers of extinguished stars when this substance gets squeezed into spaghetti-like tangles of material. It can theoretically break, but only if you apply 10 billion times the pressure needed to shatter steel. Pulsars are spherical space objects the size of a large city, but they pack more mass than the entire sun. They radiate 2 narrow beams of lights, sending them in opposite directions. The Black Widow pulsar, just like its spider namesake, is munching on its partner. It's a lightweight brown dwarf star. The more material the pulsar consumes, the more slowly it spins. The energy the neutron star is losing in the process causes its companion star to dwindle. Haumea is a dwarf planet orbiting in the Kuiper Belt, a donut-shaped ring of objects around the Sun that extends just beyond the orbit of Neptune. The mini-planet has a bizarre elongated shape and 2 moons. The day on this planet lasts just 4 hours, which makes it the fastest spinning large object in the solar system. But the most mysterious thing about Haumea is that the planet has a thin 40-mile wide ring circling it. What is it? Where did it come from? No one knows. Could be the result of a collision that happened in the distant past. The 18th brightest star in the night sky, Fomalhaut, is a terrifying sight. It's dubbed the Eye of Sauron because of a ring of dust and debris circling it. It makes the star look like a giant eye staring into your soul. The intimidating star is more than twice the mass of the Sun. It's 25 light-years away from Earth, which isn't that far away considering distances in space. Look at this butterfly. Its wingspan is more than 3 light-years, and the structure inside this nebula is one of the most complicated ever observed. The nebula's central star, a white dwarf, is heated to an incredible 450,000 AF. It means it was formed from another gargantuan star more than 5 times the size of the Sun. The white dwarf is surrounded by a thick disk of dust and gas at the equator. That's what probably makes the whole structure look like an hourglass, or a butterfly. It's dark and incredibly cold. There's no oxygen, there's no water, there's no life. But the James Webb Space Telescope doesn't seem bothered by all this. Its main goal is to find the very first galaxies that formed billions of years ago in the early universe and observe the stars making up distant planetary systems. Its mission is to… but wait, what is that? The James Webb Space Telescope has discovered something absolutely amazing, a star-planet hybrid with very strange clouds. This bizarre world, called VHS 1256b, is actually a brown dwarf. Those are bigger than planets, but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf we're talking about is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars. And to complete one orbit, the brown dwarf needs 17,000 years. In fact, astronomers found out about this unusual exoplanet in 2016. But at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb Telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Scientists have been putting forward theories about the existence of such sand clouds on exoplanets for quite some time. But the discovery the James Webb Space Telescope made is the first real proof. The silicate particles on the sandy dwarf are most likely quartz or some other mineral. In size, they're less than a micron, and 1 micron is 1/25 of a thousandth of an inch. In other words, they look like particles in smog. The exoplanet seems to have an atmosphere which contains some water, methane, and other substances and minerals. Interestingly, this atmosphere isn't still. It's constantly undergoing extreme changes. Another cool thing about it, scientists have detected carbon dioxide. And this is only the second confirmed discovery of this gas on a planet outside of the solar system. By the way, the James Webb Space Telescope, with the help of which astronomers discovered our sandy brown dwarf, is an absolutely stunning piece of equipment, around 100 times more powerful than Hubble. Even though the telescope itself is 3 stories high and its size equals that of a tennis court, its mirrors are the lightest large telescope mirrors of all time. When all the 18 mirrors of the telescope were completed during the manufacturing process, their mass was reduced by 92% in comparison to the initial discs. Each mirror weighed a mere 44 eliyabas. The telescope's mirrors seem to be gold, but in reality, they're made of beryllium, steel gray, lightweight, and brittle metal. There's indeed a gold coating on each mirror. But they can't be produced entirely out of gold, since this material tends to expand and contract even with small temperature changes. That's why the total amount of gold in the James Webb Space Telescope is less than 2 ounces. James Webb's telescope side is cooling itself down, and its temperature doesn't rise higher than 370 F. That's cool enough to make nitrogen liquid. A truly enormous 5-layered sun shield stretches around the telescope and reflects away as much sunlight as possible, letting the telescope stay cool. The telescope was launched near the equator because Earth spins a bit faster there, and this gave the rocket some extra push. The telescope orbits the sun more than 1 million miles away from Earth, and when it runs out of fuel, it'll keep orbiting the sun indefinitely. On the other hand, even though the telescope wasn't actually designed to be serviced or upgraded, it might potentially be refueled with the help of robots. This would extend its life. Anyway, if you think that our newly found brown dwarf is the only bizarre exoplanet out there, let me show you some other breathtaking worlds. There is an exoplanet that is really something else. Just look at its awesome magenta color. You can find it in the Virgo constellation. The planet is called Gliese 504b. It orbits very far from its parent star, 9 times the distance between the Sun and Jupiter. The planet formed relatively recently and is still glowing with heat. That's why its surface looks pinkish. One of the oldest exoplanets we know about, PSR B20-26b, is about 12.7 billion years old. It's almost 3 times as old as Earth. This also means that the so-called Genesis planet formed only about 1 billion years after the Big Bang. The planet is so old that its 2 parent stars have had enough time to evolve into a white dwarf and a pulsar making almost 100 revolutions per second. I bet sunrises on this planet must look awesome. Just 20 light years away from the Sun, which isn't such a great distance when we talk about space, a bizarre rogue planet is roaming the Milky Way galaxy. But even though this planet doesn't orbit any star, it still has an incredibly powerful magnetic field. It's 4 million times stronger than Earth's. The exoplanet also produces amazing auroras. That's why when it was discovered in 2016, astronomers were almost sure they had detected a brown dwarf. But later, scientists got some proof that this space object wasn't big enough to be a brown dwarf. The planet sure is a mammoth among its peers. It's 1.2 times as wide as the largest planet in the solar system, Jupiter, and more than 12 times as heavy. Astronomers think the exceptionally strong magnetic field helps the planet produce auroras. But the most curious thing is that they're generated in a different way than auroras on Earth. It might be because the exoplanet's moon helps the planet create mesmerizing light shows. The next exoplanet isn't like any other. It's often called Super Saturn or Saturn on steroids. That's because J147b has a colossal system of rings. They're 640 times as large as those our Saturn has. This bizarre world is the only planet we know about that has rings similar to Saturn's. If you moved this giant to our solar system and used it to replace Saturn, its rings would look many times larger than a full moon. An exoplanet called WASP-12b munches on the light coming from its star. It's one of the darkest worlds people know about, all because its day side consumes light rather than reflects it back into space. The egg-shaped planet is giant, twice the size of Jupiter, and it traps more than 94% of the light that reaches its atmosphere. It might be the main reason for the temperatures on the surface of the planet that can rise up to 4,600 staff. The night side of the planet isn't as hot as its day side, a mere 2,200 giraffe. The difference in temperature makes water vapor and clouds gather above the surface of the planet, and from time to time, swirls of material from the planet's superheated atmosphere spill onto its star. What a view! Discovered in 2017, Kelt 9b is one of the hottest exoplanets we know of. The temperatures there can reach 7,800 AOS. For comparison, the temperatures at the surface of the Sun reach 10,000. The planet is probably so insanely hot because it orbits extremely close to its star, Kelt 9, which is way hotter and bigger than our Sun. Experts believe that the giant star might one day evaporate the entire planet. Colonizing other planets is like the ultimate cosmic adventure. It's a challenge that has captured the imagination of humans for centuries, and it's something that we've always dreamed of doing. One of the most popular candidates for this role is Mars. And this isn't surprising. Mars is a rocky planet that is similar to Earth in many ways, and it even has evidence of water on its surface. This makes it a prime candidate for human colonization. Many scientists and engineers are working on plans to send humans to Mars and establish a permanent settlement there. But what about the other candidates? There are many planets and moons in our solar system, so why not colonize something else? For example, Ceres? Ceres is the ultimate cosmic treasure trove. It's a dwarf planet, not a full-fledged one, just like Pluto. It's located in the asteroid belt between Mars and Jupiter. This dwarf planet is the closest to the Sun, and it's adorably tiny. The entire planet is about the same size as the state of Texas. So why choose it? Because Ceres may be a rich source of valuable resources. The surface of Ceres is covered in craters and other geological features, and scientists believe that beneath its surface, it has a thick layer of water ice, which means that deep underground it may have an ocean of liquid water. If this is true, Ceres could be a valuable resource for future space missions. It could potentially provide a source of water for human exploration of the solar system. So, can we colonize it? And if so, how do we do that? Actually, many scientists and space enthusiasts have proposed this idea. To colonize Ceres, we'd have to use the same methods used to establish colonies on the Moon, Mercury, and the satellites of Jupiter and Saturn. Don't worry, it's not that hard. We just need to figure out how to adapt to a very thin atmosphere, to extreme temperatures and pressure and all the other nasty stuff. But let's stay hopeful. At the end of the day, it all comes down to resources. We'll need water, minerals, silica, and other raw materials. All this would help us to create a self-sufficient colony. And luckily, Ceres is full of these things. So first of all, we could locate the places of residence inside the craters of Ceres. We could build domes there that would protect us from all sorts of dangerous things, like radiation. We could also mine regolith in the asteroid belt. Regolith is a residual soil that appears as a result of cosmic weathering of the rock. Basically, it's something like the surface layer of soil on the Moon. Why do we need it? Well, because we could use it to 3D print the base layers next to the ice, so that our bases would be located near the water. We could then use these base layers to print other structures, like houses. We could also collect ice and organic molecules to create water, and by combining water with regolith, we would get soil in which we could grow plants and food. Wonderful. There's also another option. A colony can be created underground, that is, right next to the icy crust of the planet. Now, if in the future we'll be some kind of super cool scientists, we could try to accelerate the rotation of Ceres, which sounds crazy, but would be pretty beneficial. It would help us to create artificial gravity inside the underground colonies. And speaking of gravity, all of these things may sound cool, but let's discuss the difficulties that lie ahead of us during colonization. To colonize Ceres, we would need to overcome a number of challenges. To begin with, we need to develop technologies that will help us even get to Ceres. We need some kind of ships that would be capable of long flights into deep space. For them, first we need to create some kind of nuclear thermal or nuclear electric traction, and maybe an even more advanced type of fuel. Then we'll also need technology to help us sustain life in this small, rocky world. That is, tools to extract and use local resources. Also, since there is no atmosphere on Ceres, we would have to wear spacesuits and live in pressurized habitats. And this is only the beginning. Living on the planet itself won't be an easy task either. For example, what about extreme temperatures, or radiation, or the mentioned incredibly weak gravity? The latter is definitely one of the biggest problems. The gravity of Ceres is only 3% of the Earth's. You wouldn't want to accidentally fly into outer space while playing football, would you? But the fact that any jump could send you on an endless journey isn't the only problem. Even if you somehow stay on the surface of the planet, you'll experience the same symptoms and problems as astronauts who hang out on the International Space Station. For example, loss of muscle mass, decrease in bone density, deterioration of vision, problems with the cardiovascular system. Wow, who would have thought that gravity is so important? So therefore, if we wanted to survive on Ceres, we would need either a bunch of doctors or some kind of artificial gravity. And don't even get me started on how low gravity will slow down production and work. And of course, we can't go anywhere without discussing money. Colonizing Ceres will cost us a huge expense, especially taking into account all of the above. And yet, despite all these things, Ceres still stays one of the best candidates for colonization. For example, Ceres contains lots of methane and ammonia. They can be used as a manufactured fuel or a nitrogenous gas, or you can just mine it there in order to colonize Mars and Venus. Even low gravity has its advantages. Thanks to it, it will be very easy to launch spacecraft from Ceres. We'll waste much less fuel, which means that transportation from Ceres to other planets would be much cheaper and more efficient. So even if Ceres doesn't become our permanent residence, it can become a good transport hub, something like a spaceport. We could use it as a base for mining all sorts of useful things from the asteroid belt. Then, we could transport all these resources back to Mars or Earth, and it can also become a refueling station for ships traveling further beyond the solar system. Sounds cool and pretty sci-fi-ish, doesn't it? But it seems that any attempts to create a permanent base in the asteroid belt will have to wait. Colonizing other planets is a difficult and complex task. It will require the cooperation and expertise of many different people, and it will involve developing new technologies and overcoming many challenges. Before we go to Ceres, we need to build infrastructures on the Moon, Mars, and somewhere in between. Otherwise, any attempts to colonize it would be prohibitively expensive and would most likely fail before future missions could even reach it. But the more colonies we create, the more likely it is that sooner or later, we'll build another one on Ceres. This would not only open the asteroid belt to economic exploitation, it would also serve as a stepping stone to the outer solar system. This, in turn, could lead to colonizing the moons of Jupiter and beyond. In other words, the rewards of colonizing Ceres could be great. Not only would it allow us to explore and understand this fascinating world, but it could also provide us with valuable resources that could help us to further explore and settle the solar system. Life on Ceres would likely be challenging, but exciting, as humans would be making a new home for themselves and exploring the mysteries of the universe. Just imagine all the new planet-themed restaurants and shops we could have. Welcome to Ceres Mart, where everything is out of this world. So if you're a fan of cosmic treasure hunts, Ceres is surely a rich and rewarding destination. Just make sure you bring some weights on your feet so you don't fly anywhere.
On our good old planet Earth, water is literally everywhere. Not only in the oceans and seas, but also in the atmosphere, in the ground, and even in ourselves. It covers as much as 71% of the surface of our planet. Looks like our planet should have been called water and not Earth. But what would happen if water and land were distributed equally? What if half of the planet became land and the other half was water? Let's find out. First of all, let's discuss what we mean by equally. Despite all the things mentioned earlier, there's actually not so much water on our planet. Yeah, if you collected it all in one giant drop, it'd be slightly larger than the USA in size, and all this amount of water would be only 0.02% of the total mass of Earth. So it turns out that all these horrifying, unexplored ocean depths are basically nothing. And now, just imagine if we change the composition of our planet by leveling the volume of water and land. What would happen then? Then we'd get a very creepy ocean planet. This planet would look like one boundless ocean. It's very unlikely that you'd find even a couple of small islands on it. And if you did find them, they'd probably be the tops of huge underwater mountains. This world would be practically uninhabitable. If you were on its surface, you wouldn't be able to see the sun or anything else in the sky. You wouldn't know what time of day it is or where exactly you are, all because of the incredibly thick fog and clouds. This kind of weather would be permanent on such a planet. Moreover, you wouldn't even understand where the fog ends and the water begins, all because the humidity would be that high. But could there still be life? Maybe inside the ocean itself. Unfortunately, this is also quite unlikely. You see, to get to the bottom of this ocean, you'd have to swim vertically down not for several hours, but for several days. And even after such a journey, you wouldn't see the bottom yet. The ocean wouldn't be bottomless, of course, but the seabed would consist mainly of very hard, impenetrable ice, but not the kind of ice we're used to. This ice would be exotic. There are different types of it, called Ice V, Ice VI, and so on. Usually, these types of ice aren't as cold as regular ice and may not melt even at very high temperatures. And there would be almost no algae or anything like that, so fish would simply have nothing to eat. That's why if life appeared on such a planet, it would be a miracle. This life would have to withstand a pressure of more than 20,000 Earth atmospheres. Even the most horrifying monsters from the Mariana Trench would be nothing in comparison to the creatures you'd find on this ocean planet. But could we, humans, live there? Well, theoretically, yes. But it would be extremely hard. We could create something like giant underwater stations, but we would still have thousands of problems. Where to get food and other resources, how to repair stuff, and so on. So it would be far from the best option. Okay, now we know that an ocean planet doesn't sound too endearing. What about another option? What would happen if the surface of Earth was 50% water and 50% land? For this to happen, we'd need to reduce the current amount of water from 71% to some 50%. In this case, the sea level would drop by about 2 miles, and about a quarter of our planet would become dry land. Although it doesn't sound like much, the consequences would be disastrous. Right now, there are 5 interconnected oceans on Earth: Atlantic, Indian, Pacific, Southern, and Arctic. But if we lowered the sea level, all these oceans would simply disappear. They'd turn into separate closed reservoirs and seas. On the contrary, all the continents would merge into one giant landmass, almost as if we swapped the land and water. And at first, it would seem pretty cool. Now you'd be able to literally walk around the world. However, the amount of land you'd have to travel would also increase. Every continent on the planet would grow in size. All this new territory would be approximately equal to the current area of Asia, Europe, Africa, and North America combined. Well, That would be a huge mass of unused space. But what would we find on these new territories? Most of them would be pretty flat, but in places where there used to be deep oceans, you would see vast corridors and steep crevices. Here's another cool thing. Most of the sunken cities would return to the surface. And no, unfortunately, we wouldn't find Atlantis among them, but there would still be a lot of other cool places. For example, the ancient Roman city of Baiae, which, according to legends, was basically a paradise on Earth with all its luxurious villas and gardens. Or Heraklion, the city that went under the sea thousands of years ago and was considered a myth for a long time. So yeah, we could organize tours to these ancient places. But of course, not everything would be fun and games in such a world. Due to such a severe loss of water, ocean currents would be disrupted, and this would lead to very serious climate problems. The ocean absorbs the heat radiated by the sun. Thanks to the currents, this heat is distributed all over Earth, which creates a stable and pleasant climate. But if these currents were disrupted, then the temperatures on Earth would become more extreme. It would get much hotter near the equator, and even colder around the North and South poles. So yeah, unfortunately, the Antarctic ice wouldn't save us. It would be quite the opposite. The regions around the North and South poles would completely dry out, basically turning into dry, cold deserts. In addition to heat, water also absorbs carbon dioxide from the air. And since the oceans wouldn't be able to absorb it, this gas would begin to accumulate in the atmosphere. This poisonous excess would cover the entire planet. The average temperatures would increase, and the whole planet would start to dry out slowly. Massive forest fires would break out, and so on. Sound familiar? To make matters worse, there would be nothing to extinguish these fires. Because, you know, rains can't form from nothing. So yeah, the precipitation levels would fall, and this would lead to dangerous droughts. We'd get a bunch of new deserts on all the continents. Despite getting all those new territories, it's unlikely that we could somehow build new cities and towns there. Many of these territories would be uninhabitable. Not only because many forests and plants would disappear, but also because most animals would migrate to more pleasant places. As a result, we would have great difficulty finding any food at all. So all life on our planet, plants, animals, and people, would have to adapt to new living conditions. They would have to evolve quickly and get used to the constant shortage of water. Animals, for example, could shrink in size because of this. Many of them, due to the lack of grass and moisture, would switch to a strictly carnivorous diet. And of course, we would have to say goodbye to the huge abundance of marine life. Many fish would disappear forever. Humans most likely would make a big evolutionary leap backward. Not only because we would lose a large number of resources and move to new territories, but also because we would also lose access to one of the most important sources of energy in the world, hydroelectric power plants. Without electricity, many factories would stop working. To say that this would cause a large-scale crisis for us all is sadly obvious. So, our current ratio of water and land is the best possible option. If there was too little or too much water, the consequences would be awful. That's why we need to protect the current conditions with all our might.
Have you heard about Planet 9? No, not Pluto. We're talking about something lurking on the outskirts of the solar system. A mysterious planet that exists in our solar system that we haven't yet discovered. We've been looking for it for years, but finally, it seems like scientists found a key to solve this mystery. Planet 9 is a hypothetical planet. Astronomers have been on the hunt for it for quite some time now, but it's so elusive that they've only been able to piece together a few details about its potential characteristics. One thing we do know is that Planet 9 has to be a massive world, possibly up to 10 times the mass of Earth. That's one big planet. It's also thought to be a distant wanderer, hanging out somewhere between Neptune and Pluto. Some scientists think that Planet 9 might actually be a mini Neptune, with a thick, gaseous atmosphere and a rocky core. Others speculate that it could be an icy world with a solid, frozen surface and a thick layer of hydrogen and helium gas. Of course, since we haven't actually found Planet 9 yet, we can't say for sure what it's like. We're not even sure that it even exists. Some say it's just a myth, like the Tooth Fairy or the Easter Bunny, but others are convinced that it's out there somewhere. And at the end of the day, we're not entirely sure if Planet 9 is even a planet. It might be a special kind of black hole or made entirely of dark matter. The search for Planet 9 began in the early 21st century when a group of astronomers realized that something wasn't quite right with the outer reaches of our solar system. They noticed that some distant objects, known as trans-Neptunian objects, were behaving in unexpected ways. Trans-Neptunian objects, or TNOs, are like the cosmic version of those items in the back of your fridge that you forgot about for years. They're small, icy bodies that hang out in the Kuiper Belt, beyond Neptune. So, scientists noticed that these guys started behaving weirdly. At first, they thought it might be a fluke. But as they dug deeper, they began to suspect that there was a ninth planet lurking out there. Why haven't we discovered it yet, you ask? Well, it may be because of Planet 9's weird orbit. All the other 8 planets orbit the Sun in roughly the same plane, which is like a flat disk. However, our hypothetical friend's orbit is different. It might be tilted and move in a different direction compared to the other planets. Its orbit might also be stretched out like an oval, rather than being nearly circular like usual. Because of this, Planet 9 might spend most of its time far from the Sun, like a true introvert. It only comes relatively close to the inner solar system every few thousand years. This would make it super faint and hard to spot, so the only way we may discover it is by studying the gravitational effects it has on our solar system. And this isn't the first time astronomers have gone looking for a new planet. Back in the 19th century, there was a similar hunt for a hypothetical Planet X. But this time, they were armed with much better technology and a much better sense of humor. They began calling their elusive quarry Planet 9, which was much catchier than Planet X. They even came up with a hashtag for the search, Pluto Lives. It was a reference to the fact that Pluto had been kicked from the planet gang and some astronomers were eager to find a new planet to take its place. But the search for Planet 9 has been no easy task. It's like trying to find a lost sock in the laundry basket the size of a football stadium. It's so far away and so faint that even the most powerful telescopes can't see it. Instead, astronomers have had to rely on indirect evidence, like the strange orbits of TNOs, to try to figure out where it might be. Some scientists have even supposed that it might be a wandering rogue planet, which would explain why it's so hard to find. But they haven't given up hope. Till this day, they're scouring the skies using all sorts of high-tech telescopes and fancy algorithms to try and spot this elusive planet. And fear not, dear curious human, because it looks like after so many years of research, we may have finally found the key to solve this mystery. Astronomer Man Ho Chan from Hong Kong has a theory. He believes that Planet 9 could have a bevy of moons. That's right, not only is it a giant planet hiding out in the depths of space, but it's also a bit of a hoarder. Moons are all the rage in the outer solar system. In fact, almost every planet here has at least one moon, except for Mercury and Venus. Earth has just one, which is kind of sad if you think about it. Even non-planetary bodies like Pluto have at least a couple of moons. A bit unfair, isn't it? Anyway, taking this into account, let's go moon picking with Planet 9. The region between the rock-filled Kuiper Belt and the rock-filled Oort cloud, where this planet is predicted to be, should be ripe for the picking. Chan made some calculations and determined that it would be stranger if the elusive planet didn't have any satellites. According to his calculations, an object the mass of Planet 9 should capture at least 20 TNOs as large as almost 90 miles across. It's like our mysterious planet is playing cosmic Pokemon with these guys. So, what if Planet 9 has moons? Would that make any difference? Kinda, yes. They could give us some indirect clues to finally locate this mysterious planet. Now, you might be thinking, how in the cosmos can we possibly spot these teeny tiny moons? It's not like they're going to wave a giant flag or blast some Beyoncé tunes to get our attention. Well, apparently the key lies in something called tidal heating. Tidal heating might sound like a new workout trend, but it's a real scientific phenomenon. It happens when two celestial bodies are close together. You see, tides aren't just about the rise and fall of the ocean, they're also the result of gravity pulling unevenly on a planet or moon. When a planet and a moon are close enough to each other, their gravity pulls on each other, creating a bit of a football shape. And as these celestial bodies move around each other, they shift shape and generate friction inside, which produces heat. Wow, who knew that Planet 9 could have a workout routine? Perhaps we should start calling it Gym Planet instead. Anyway, if Planet 9 has any moons, the gravitational pull from these moons would cause it to change shape constantly, generating heat in the process. And we might be able to detect this mysterious planet through the heat produced by those moons, even though it gives off no other signals. Now, before you get too excited, finding them won't be a walk in the park. They're incredibly small and would be very far away from us. But hey, nothing worth discovering ever came easy, right? Scientists are optimistic that with the right technology, they can spot this telltale sign. It will be easier for us to spot them with fancy instruments like modern telescopes. Talk about cool friends to have, right? Sure, the process of finding it may be difficult and time-consuming, but the potential payoff is huge. Finding this planet could explain a lot of the strange behavior observed in TNOs, the Kuiper Belt, and beyond. As we've already mentioned, they've been acting super weird lately, tilting and aligning in suspicious ways. If this planet doesn't actually exist, we have yet to explain what is the reason for this strange behavior. In any case, the search for Planet 9 is one of the most exciting and intriguing quests in modern astronomy. It's like a cosmic scavenger hunt, and everyone's invited to join in on the fun. So, grab your telescopes and let's go planet hunting. Who knows, maybe we'll find it sooner than we think.
So, we might be getting closer to finding a massive icy planet beyond Neptune's orbit. Sorry Pluto, still not you. Recently, some universe mapping using data from a telescope in Hawaii eliminated about 78% of the possible locations for this mysterious Waldo from space. Some people call it Planet 9, while others prefer Planet X. Either way, it's been causing controversy since its existence was first proposed, and that is mainly because no study so far can answer the big question: does it really exist? If discovered, Planet 9 would rank as the fifth largest planet in our solar system, with a mass 10 times that of Earth. It's also theorized to be gaseous, like Uranus. The initial study on Planet 9, dating back to 2016, suggests that this colossal new planet orbits the Sun 29 times farther out than Neptune, which sits at about 2.8 billion miles. As a result, the Planet 9 would take between 10,000 and 20,000 years to complete a single orbit around the Sun. If confirmed, this yet-to-be-understood world would dominate a region larger than any other known planet in our cosmic neighborhood. These are all intriguing hypotheses, but without a single piece of evidence or observation to back them up. Before dismissing this as a wild guess, it is important to note that these researchers relied on complex mathematical modeling and computer simulations to speculate about the planet's characteristics, because that's what they do. The hypothetical presence of this planet would explain various mysterious features located beyond Neptune. We are specifically talking about the Kuiper Belt, a huge donut-shaped region filled with icy debris left over from the formation of the solar system, including comets and dwarf planets like Pluto. What happens is that the 6 farthest objects in the Kuiper Belt exhibit elliptical orbits that are all oriented in a similar direction within physical space and tilted approximately 30 degrees downward relative to the orbital plane of our 8 known planets. What's strange here is that, despite their distinct orbital velocities around the solar system, they maintain this alignment. The likelihood of such alignment occurring randomly is extremely low, around 0.007%. So, here comes Planet 9, a hypothetical massive celestial body that offers a plausible explanation for this strange phenomenon, potentially exerting gravitational influence to shape these orbits. The initial theory didn't hold up for long, facing accusations of observational bias and calculation errors. Then, in 2017, another study popped up, sparking back the idea that maybe Planet 9 is out there after all. This time, Spanish astronomers tried a novel approach, focusing on observing extreme trans-Neptunian objects. These celestial bodies orbit the Sun in highly stretched elliptical paths, with average distances exceeding 13 billion miles. The research suggests that the distances between these objects' nodes and the Sun might provide clues to Planet 9's location. You see, these nodes are the points where a celestial body's orbit intersects the solar system's plane. When these objects reach these points, they're more likely to interact with other solar system bodies, potentially causing significant changes in their orbits or even collisions. So, if the trajectory of these extreme trans-Neptunian objects remains stable, everything's fine. But if it's not, well, that's a sign that something else, something big, is messing with their path. And that's exactly what the research found. There is something unseen out there, throwing these objects off course. And that something could be a planet, chilling at a distance between 300 to 400 times farther from the Sun than Earth. To this day, the study of the extreme trans-Neptunian objects is the strongest evidence we've got for Planet 9's existence. And if you're still not convinced by this theory, know that strange motions like these have led to planetary discoveries before. Neptune, for instance, was spotted because Uranus's motion didn't quite agree with the predictions of Newtonian gravity. But the deflection of its orbit could be explained if it was caused by a pull of an undiscovered planet. And just like that, we discovered Neptune. Now, the year is 2021, and there's all this buzz about Planet 9 again. After correcting some old guesses, studies are now leaning towards the idea that this mystery world follows an epic loop around the Sun every 7,000 years. That is massive news, because it means this planet might be closer than we ever thought, making it easier for our telescopes to spot it. The paper also suggests there is a whopping 99% chance that the funky orbits of these distant objects are all because of this unseen planet, not just some cosmic coincidence. Now, the odds of this whole situation being a fluke are down to a 1 in 250 chance, which is much better than the 1 in 10,000 chance back in 2016. All these optimistic numbers have brought us to where we are today, keeping our hopes and working on better equipment to continue the mission of spotting Planet 9. As mentioned earlier, researchers in Hawaii created some kind of treasure map utilizing the Panoramic Survey Telescope and Rapid Response System to eliminate 78% of its locations. This is great news, considering how challenging it is to find a planet-sized needle in a cosmic haystack. But unfortunately, Planet 9's presence remains a ghost in the dark outer reaches of our solar system. Enthusiasts are still convinced of its existence and believe it is only a matter of time before we celebrate the discovery of Earth's new cosmic cousin. They're putting their hopes on the Vera C. Rubin Observatory, which is currently under construction in Chile and is scheduled to begin science operations in late 2025. Over the course of 10 years, this observatory will scan the entire southern hemisphere sky every few nights with a 27-foot, fast-moving telescope equipped with the largest digital camera in the world. The idea is to catalog everything in the solar system, reaching out to and beyond Neptune, and tracking the movements of millions of celestial objects, including space junk, asteroids, comets, and stars. If Planet 9 is indeed out there, This next-generation telescope could be the one to find it. The existence of this mysterious planet is far from being universally accepted in the scientific community. That is simply because Planet 9 isn't the only explanation for the strange phenomenon occurring beyond Neptune. One theory suggests that a group of distant objects, such as dwarf planets, comets, and moons, might be collectively influencing the orbits of the extreme trans-Neptunian objects. Others believe that a black hole is behind all this. These compressed masses are some of the densest objects in the universe, potentially capable of affecting the orbits of other masses, like how this supposed ghost Planet 9 is believed to be doing. Another bold perspective suggests that our current understanding of the laws of gravity is flawed, actually incomplete. This theory, known as modified Newtonian dynamics, proposes that these distant icy objects exhibit strange behavior not due to influence from another planet, but rather because the immense gravitational field of the Milky Way is influencing them. However, even supporters of this theory acknowledge that it is too early to draw firm conclusions, and much more extensive research is still required. While we continue our relentless hunt for Planet 9, some astronomers have taken it a step further, suggesting the existence of a hypothetical Planet 10. This world has a mass and size like that of Mars or Earth and is located on the edges of the Kuiper Belt. But the thing is, if this alleged Planet 10 is indeed as small as scientists believe, it might not have enough gravity to clear its orbit of debris. And that is pretty similar to what happens with Pluto, being one of the reasons why it got into trouble back in 2006. So yeah, it's better not to get too excited. This supposed Planet 10 might end up classified as another dwarf planet.
Whoa! A wall of fire spreads around the epicenter of the impact. It burns everything in its path. The waves raised by the explosion cover large cities, and earthquakes are so strong that giant skyscrapers fall like a house of cards. So, these are the possible consequences of the collision with the first interstellar object in history to visit our solar system. We discovered it in 2017, but we're still not sure what it is. An asteroid, a comet, or a spaceship of some outer space civilization. So far, scientists have named it Oumuamua. Sounds like a Hawaiian cow. Well, whatever it is, its speed is much faster than other asteroids, about 54 miles per second. At that speed, you could cross the US from coast to coast in less than 3 minutes. So this asteroid could travel from Earth to the Sun in about 2 months. By comparison, our rockets can travel up to 17,000 miles per hour. The same trip across the United States would take them about 9 minutes. So, many scientists speculate that this is an artificial object created by a very advanced civilization. Okay. The shape of the object supports this theory. It's long and narrow and resembles a spaceship. It's about half a mile long, way bigger than the Eiffel Tower. Scientists decided to see if Oumuamua was really someone's spaceship and pointed some radio telescopes at it. If the civilization on that ship had used communication or scanned us with their tech, we would have known about it. But there was complete silence. Kind of like that. Not a single radio wave. But that doesn't disprove the theory of outer space civilization. To find out for sure, we decided to determine the weight of the object. To do that, we use light. More precisely, its reflection. You see, different materials reflect light differently. We take an unknown black stone, for example. It absorbs almost all the light, reflecting almost nothing. Check out the catalog, it's charcoal. Knowing the size and material of the object, we can determine its weight. So, we need to see how much light this object reflects. And when scientists pointed their telescopes at Oumuamua, they learned that it reflects colors that match with iron and also with some solid rocks. And Oumuamua was flashing all the time, a bright flash. Then it would slowly fade, and then it would start to shine again. This means it was spinning. And it wasn't going around its axis like an arrow. It rotated chaotically, moving its edges up and down. Any artificial object or spacecraft would have been torn apart by such overloads. But Oumuamua is still intact.
That means it's made of super hard materials that keep it from falling apart. And it's not hollow like a spaceship. It's one solid body. Hey, like me. The astounding speed of this object makes it pretty mysterious. Some comets can have the same or even higher speed, but they also have a kind of rocket effect. So when a spaceship starts from the launch pad, you see fire bursting out of its engines. Every second, the rocket mixes fuel with oxygen, ignites them, and ejects them at a tremendous speed. According to the laws of physics, this is like pushing off a wall. The rocket sort of jumps up from the combustion gases it throws down. That's how the rocket creates thrust and accelerates. Comets work on a similar principle. The sun's rays hit the surface of the comet. Light elements like ice start to evaporate. That gas goes one way, the comet goes the other. Just like a rocket, the comet is pushing off the evaporating gas and accelerates. This gas also forms the comet's long tail. It's as if the massive rock is dragging all this gas behind it. I can relate. Or it's like a car pulls air with it when it goes at high speed. But Oumuamua is not a comet, and it doesn't have that tail, and it doesn't have the same rocket effect as a comet. So it couldn't have accelerated to that speed. But some scientists believe that Oumuamua used to have a tail. Although we discovered it in 2017, it entered our solar system in 1995, and it was hit by the sun's rays even back then. When we discovered this asteroid, it had already lost about 95% of its mass. It simply evaporated. Other scientists believe that Oumuamua got this velocity during its birth, somewhere far away in another star system or nebula. Perhaps it was a dramatic collision of some exoplanet with another cosmic object. The colossal explosive energy of the collision threw the elongated shard into outer space. Or it could have been a supernova explosion. When a star reaches the end of its lifespan, it becomes a red giant. It's an inflated version of the star, hundreds of times bigger. Then it shrinks and explodes with tremendous force. The blast waves can travel many light years away from the epicenter, and it's one of the brightest events in the universe. So the supernova might have torn some exoplanet to pieces. One of them, Oumuamua, gained a lot of energy and speed and began its long journey toward Earth. This might explain why Oumuamua keeps spinning so wildly. But recently, scientists published a theory that Oumuamua may be a giant block of ice. The kind of ice we're used to is water, H2O, but Oumuamua could be nitrogen ice, N2. It may have remained intact in interstellar space for 500 million years. And when it arrived in our solar system, nitrogen ice could have reflected 2/3 of the sun's rays, so it didn't heat up as much. That explains why Oumuamua doesn't have a tail. You can find the same nitrogen ice on Pluto, as well as on Triton, one of Neptune's moons. So Oumuamua comes from a similar icy exoplanet. But we can find out for sure only by sending a space probe to it. Scientists came up with a plan for that called Project Lyra. The problem is that Oumuamua is leaving our solar system at tremendous speeds, much faster than our rockets can fly. And we need to catch up with this space rock as quickly as possible before it gets too far away. To do this, we can use a gravity maneuver. First, the space probe makes a flyby of Jupiter. It passes close to it to take advantage of its gravity to accelerate. After that, the probe will head towards the sun, and it'll fly around it as close as possible to fire like a catapult towards the space rock. The second option for reaching the asteroid is to use microprobes. We have to launch about 1,000 of them into orbit. They should be no heavier than a match. Each of them will have a light sail the size of a boxing ring. Then we'll focus a powerful laser beam from the ground onto this sail. It will allow us to accelerate the probe to about 20% of the speed of light. It shouldn't go too fast not to fly past the asteroid. It should be able to enter its orbit or land on it. But if we're too slow, Oumuamua will leave our solar system before we can catch up with it. It'll be a great experience because in the future, we'll be able to use such asteroids as a space taxi. All we have to do is enter the orbit of such an interstellar asteroid or even land on it. Then we would keep moving through space at incredible speeds without using any fuel at all. This would be a great option for traveling long distances or to deliver supplies to other star systems. So why should we be afraid of such objects? Well, a collision with an asteroid the size of Oumuamua could wipe out an entire state. If it were to hit somewhere in the ocean, it could cause waves taller than our skyscrapers. Scientists are anxious to find ways to protect us against such objects. One of them is ramming. If we spot a potentially hazardous object, we could send a spaceship towards it, pedal to the metal. The spacecraft will have to ram the asteroid at an angle that will move its trajectory just a little bit. Moving it too much on a cosmic scale would only dramatically change the asteroid's final destination, and we only need to get the asteroid past our planet. We can also create a controlled explosion on the asteroid. It's based on the same principle. The force of the explosion would have to shift the trajectory of the asteroid slightly, or smash a giant rock into smaller pieces. Asteroids up to 80 feet wide would burn up completely in our atmosphere due to friction against the air. Rocks between 80 feet and half a mile in size may not burn up completely and cause local damage. Anything larger is considered very hazardous. You think? The traditional method of science fiction is to put rocket engines on the asteroid. Then we can not only change the trajectory of the space rock, but also control it. And we can use it against other asteroids. It would be something like space billiards. As you know, all the planets in our solar system orbit the Sun and bring a sense of order to the place. But guess what? There are two planets that could collide with each other and cause a cosmic catastrophe. Here's Neptune, the most faraway planet in our solar system. It's 17 times heavier and 4 times bigger than the Earth. It's 30 astronomical units from the Sun. 1 AU is the distance between the Sun and the Earth, so it's 30 times farther away from our star than we are. And Neptune makes a complete circle around the Sun in 164 years in an almost perfectly round orbit. Neptune is cold, calm, and stable. But there's one planet that can ruin this balance: Pluto. It's a dwarf planet covered in rocks and ice. It's 6 times lighter and 3 times smaller than the Moon. We're interested in its orbit. If you look at a map of the solar system from above, you can see that it's not round but elliptical, so it's a slightly flattened circle. At its furthest point, Pluto is 49 Earth-Sun distances away from the Sun. When it moves, it comes closer to the star. At its closest point, Pluto is about 29.5 AU from the Sun. That's closer than Neptune. So, hypothetically, they could collide. Let's look at this collision from the front row. A little closer, please. Good. Neptune and Pluto are slowly approaching each other. They are both very cold worlds, but they begin to interact with each other gravitationally. Just like two magnets, it warms them up from the inside. Neptune is a gas giant. There's no solid surface there, so there's not much change in it yet. But Pluto has a rocky surface. Because of Neptune's gravitational influence, it's starting to crack. Pluto experiences continuous earthquakes. This causes it to heat up even more. When Pluto almost touches the gas giant, it begins to crumble from the inside out. Plus, Neptune has a very dense atmosphere. So the dwarf planet begins to ignite from friction with the gases in the upper atmosphere. Pluto is now very hot on one side and very cold on the other. This causes severe deformation, and it begins to crumble. Half of the dwarf planet's fragments remain in Neptune's orbit. They will collide with each other until they turn into dust and become new rings of the big planet. Other fragments will burn up in Neptune's atmosphere. And the biggest rocks that remain of Pluto will fall through Neptune until they're completely burned into dust. Neptune literally ate Pluto and continued its orbit without any change, all because the gas giant is 20 times larger and much heavier than the dwarf planet. So this collision would do no harm to Pluto. But it couldn't have happened in the first place, because their orbits don't actually cross. Let's look at the map of the solar system again, not from above, but from the side. All 9 planets here are on a horizontal line from the Sun. The distance between them is great, and their orbits don't cross. Here's Pluto's orbit. You can see that it's tilted relative to the horizontal line of all the other planets. It starts at the top, then dives under the orbits of the planets and comes back. So Pluto can never collide with Neptune. Still, planetary collisions have occurred in our solar system before, and thanks to these collisions, life appeared on Earth. Let's go back in time to almost 4.5 billion years ago. This ball of hot lava is Earth. It just formed from a cloud of dust and began to cool. But then, a wandering planet the size of Mars appeared on the horizon. It's called Theia. It was inevitably approaching our planet. The collision with Theia happened at a perfect angle. If Theia had hit us head-on, both planets would have been smashed to pieces. But it hit us almost at a tangent. Theia knocked some of the matter out of the young Earth and crumbled into rubble itself. It could no longer continue its journey because the Earth caught it in a gravitational trap. A large fragment of this planet remained in our orbit. Smaller fragments crashed into each other, falling to Earth or joining the remains of Theia. The dust settled, and we can see the familiar picture, the Earth and the Moon. This is the main theory of how it came to be next to us. Scientists say that it was this collision that caused life to appear on Earth. Theia brought a lot of ice on it, which turned into water on our planet. The new moon stabilized Earth's rotation, and conditions on the planet became perfect for the emergence of life. Another collision could create a blast wave that would spread out thousands of light years. Stellar collision. This usually occurs in binary systems with a white dwarf and a regular star like our Sun. A white dwarf is the remains of a star that has gone out. As the stars get together, they start to move around each other in a spiral-like dance. The white dwarf pulls down the upper layers of the larger star. This hot plasma and stardust form a luminous disk. The two stars get closer and closer. When they finally merge, this causes a chain reaction in the core of the hot star. The mass of matter presses on the star's core too hard. This causes the innards of the combined star to heat up even more, and it expands, creating a supernova. This is one of the brightest events in the universe. The light from the explosion can be seen hundreds of light years away. Another spectacular view is the collision of a star with a black hole. Black holes are the heaviest objects in the universe, and their gravity is incredibly strong. So, when a star and a black hole get close, the black hole starts eating the lighter matter of the star. The hot plasma, like spaghetti, heads toward the heart of the black nothingness. For an observer, this plasma seems to settle on the very edge of the black hole. It's called the event horizon. The thing is that time is much slower near such a heavy object. So we think the matter stays on the event horizon, but in fact, it's long gone into the heart of the black hole. As they get even closer, the black hole starts to literally tear the star apart and swallows it whole. At this point, the black hole spits out about half of the star's mass in the form of a beam of energy right out of its black heart. The other half of the star's mass becomes the black beast's food. We know of many black holes in our universe. The heaviest of them usually lies in the centers of galaxies. They can be millions of times heavier than the Sun. But what would happen if two black holes collided with each other? Our scientists had the opportunity to observe such an event. Two black holes weighing 66 and 85 solar masses gradually approached each other. They danced together, bending the light passing by them. But then they merged into one enormous black hole, weighing 142 solar masses. That same second, the new black hole released gravitational waves into space with an energy of 9 solar masses. Scientists were able to catch these waves and observe the merging of the two black holes from the front seat. But this event actually happened about 17 billion years ago. We're only now seeing it because the particles of light and gravitational waves took so long to travel the distance of 17 billion light-years to Earth. Now consider a galactic scale collision. Literally, it's a collision of the Milky Way and the Andromeda Galaxy. This event will happen in 4.5 billion years, so stay tuned. The Milky Way has almost 100 billion stars. Andromeda has about 1 trillion. As the galaxies approach one another, they'll make several circles around each other. At that time, some stars may be ejected from the galaxies like from a slingshot. Then Milky Way and Andromeda will begin to merge. One scenario here is that our solar system will collide with another star system from Andromeda. In this case, there could be a stellar collision and a supernova afterwards. Our world would be destroyed. Another option is that the Sun would be ejected into dark space. In this case, we may not even notice the difference. All we'll see on Earth is a gradually disappearing starry sky, as our solar system will travel through dark space away from the home galaxy. But the most likely scenario is when the galaxies merge, it'll be completely painless for us. In fact, the space is very wide, and there's room for all the stars from both galaxies. The only difference is that we'll see a lot of new stars in the night sky, along with flying saucers from Andromeda. Nah, not really. But it's not the collision of galaxies that we should be worried about, it's our Sun. In 4.5 billion years, it'll become a red giant. It'll expand, swallowing up the nearest planets. Earth will probably be the first planet near the Sun. It'll be so hot that all life will simply disappear, and no one will be able to watch the galactic collision.
NASA sent a spacecraft right into the Sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the Sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the Sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the Sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the Sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the Sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The Sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the Sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the Sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast, when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the Sun went off the page, Literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then, it will descend to one of the largest basins on the moon and spend 1 lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket. Right now, 4 tiny, Earth-like planets are chilling around one of the closest star systems to us. We're talking second closest. These little rocky worlds are each about 20 to 30% the mass of Earth. So not quite Earth 2.0, but still pretty solid. Will one of them become our new home one day? Well, all of them are pretty close, so future humans might actually visit them someday. Not like next year or anything, but
we could potentially send missions there. Don't expect any extraterrestrial neighbors, though. Those planets probably aren't home to life, or at least not anything we'd recognize. Let's take a look at them. The planets are called Bernard B, C, D, and E. How creative, huh? The innermost has a mass of 26% of Earth. The second one is a bit bigger, with a mass of 30% of Earth. The third one has 4% more mass than the previous. And the outermost is... no, it's not the biggest. Actually, it's just a baby, with a mass of 19% of Earth. All the planets are likely rocky, like the inner planets of our solar system. They orbit their star very closely. That's why they only need a few days, under a week, to make a full circle. Now, what about that star these little guys are circling? It's called Bernard's star. Astronomers have always had a hunch there might be at least one planet orbiting it. First off, this star is super close, in cosmic terms, of course. Only the Alpha Centauri trio is closer to us. Bernard's star is just under 6 light-years away, which is basically next door. At the same time, it's not like our Sun. Bernard's star is a red dwarf, the most common kind of star out there. It's got only about 1/6 the mass of the Sun. But red dwarfs are a goldmine for learning about planets outside our solar system. And studying Bernard's star can help scientists figure out what planets around single stars, like our Sun or this red dwarf, are like. Or what kind of environments red dwarf planets might have. And most importantly, we might finally find the answer to this super important question. Could any of these places actually support life? For the longest time, scientists thought there might be a big Jupiter-like gas giant hanging out near Bernard's star. All because the star has a little wobble. It looks as if it shifts towards and away from Earth over time, so something might be tugging on it. Interestingly, it wasn't a giant planet doing the pulling. According to a study from March 2025, it's actually 4 smaller rocky planets, each about 4 times the mass of Mercury. One day, they ganged up and started tugging on the star together. These planets are incredibly close to their star, so close that they can whip around it in just a few days. Sadly, because of that, they might be way too hot for anything like life. Besides, since these 4 seem to explain all the star's movement, the researchers think there's probably nothing else orbiting the habitable zone. So, there's no Earth 2.0 orbiting around Bernard's star. Still, it's an awesome find, especially since this star is basically our cosmic neighbor. Plus, the system might not stay off limits forever. With nuclear fusion engines or light sails, futuristic propulsion systems that could make the trip way faster. We might probably go there one day. And then we'll finally figure out if these worlds are really lifeless and maybe even colonize them. Now, let's see how scientists found the star's hidden planets. Normally, astronomers spot exoplanets when they catch them crossing in front of their stars and blocking some light. But Bernard's star is tricky, because in our view, it's like we're looking from above the system, so its planets don't block the light in the usual way. That's why they call it the Great White Whale of planet hunting. To get around this, researchers used a super sensitive instrument called Maroon X attached to the Gemini North Telescope on Hawaii's Mauna Kea volcano. Over 112 nights, spread out across 3 years, the telescope picked up tiny changes in the star's movement. These shifts let scientists figure out how many planets must be tugging on the star, as well as estimate their sizes. At first, they found 3 planets. But then they used another device, deliciously called Espresso, and located at the Very Large Telescope in Chile. And only after a shot of this espresso did they find a 4th planet. By combining the data from both instruments, they were able to more or less confidently say their findings were solid, not just random glitches in the data. Even though red dwarfs, like Bernard's star, are the most common type of star in the universe, most are way too far for us to see planets around them easily.
These new findings suggest that small rocky planets could be pretty common around these stars, and that's huge for future discoveries. Now, finding new exoplanets is cool and all, but it might be even more exciting to dwell on their birth and evolution. And a recent study has made the sweetest discovery ever. Newly born exoplanets might actually look like Smarties, that popular British candy, rather than spheres. We've always kinda assumed that baby planets are born ball-shaped, but they might be oblate spheroids instead. A team of scientists from the University of Central Lancashire in England used computer simulations to build a model of the formation of planets in dense gas disks surrounding young stars. After that, they compared these models with actual observations and noticed that the young planets took pretty unusual shapes. The thing is that even though almost 6,000 exoplanets have been discovered so far, astronomers still don't have a clear understanding of the sequence of events marking their birth and early evolution. But this new research might finally shed light on this process. So, the astronomers examined the formation mechanisms of gas giant planets like Jupiter and came to the conclusion that planets built up from their centers. After that, the researchers focused on the initial shapes of such planets. They were also interested in how they could encourage the growth of these planetary seeds. How could they turn into such massive planets, some of them bigger than our solar system's largest giants? According to the standard theory of the formation of planets, such growth happens gradually and smoothly. First, dust particles start to stick together, turning into larger and larger objects. This process lasts for a very long time and is known as core accretion. It's the model of planet formation scientists favor. There's another theory, according to which planets' birth might happen over shorter periods of time. This data involves a protoplanetary disk, a disk of gas which makes up 99% of its mass, and dust, around 1%. This disk orbits a newly formed star, and hypothetically, planets might form from this cloud. Protoplanetary disks are likely to be common byproducts of star formation. They might range in mass from 0.001 to 0.3 solar masses. Inside such disks, matter slowly moves inward, and dust particles grow bigger, to the size of pebbles. At one point, after 2 to 3 million years, a giant rotating protoplanetary disk breaks into pieces, and that's how baby planets are born. This theory is known as the disk instability model. As for the model built by the team, it seems to support this second, less favored theory, rapid planet formation through disk instability. All because this theory explains how large planets can form relatively quickly at pretty large distances from their host stars. As for the weird flattened shape of these newly formed planets, it might be due to the material falling onto them. Most likely, it goes mainly to the poles of new planets. One of the main conclusions of the research is that the appearance of young exoplanets, as we see them from Earth, may vary depending on how they're angled. If Earth is directed face-on to an exoplanet, it will seem that the latter has a traditional spherical shape. But if seen on edge, a baby exoplanet will look like a real Smartie. The team is going to continue to investigate the formation of planets with the help of an improved computer model. They believe they can find out the role the environment around a young planet plays in affecting its shape and formation.